I'm gonna wait to see if it's streaming. I'm gonna try something different today, which is just to not worry about the time and then just rest whenever I feel like it. I'm gonna leave the chat open, but it might take a long time to reply if someone asks something or says something. Just trying to see if I can induce flow states. And I'm very tired. I've been tired the last couple of days. I think it's just because of the whole Buildspace thing. There's a lot of pressure, I think. Because I'm committing to this in public, so I feel like I have to try my best to do all of the updates and make sure that I complete everything. So it's kind of exhausting to even though I'm not working, I think, more or less than I did before. The thing is kind of like a mental thing. So I'll put some music here and then. Today I'm just gonna see if I can. I'm gonna try to change stuff on here. Maybe I'll do another branch, and then I'll just see play around with this. See if I can do some other animations. I wanna make the mouse zoom effect, and then try to see if I can put constraints on the thing, or change the way that I'm doing the edges so it looks better. think I'm gonna have to look at the source code, because I don't understand how I'm supposed to do it. Like if I'm supposed to put the event on the interaction and how that interaction is related to the stage here. Because I don't, like, the whole issue is that stuff that I talked about previously, which is that this is a black box for me, that I don't understand really well what's going on under the hood here when it creates the stage. So I imagine that it's creating a context for the app, and then you can access the context either by setting the app on mount here, and then the app is gonna be like the normal Pixi app that they are talking about there on the documentation, so I'm gonna have access to these methods here. But then the question is like, how should I do it? What are the methods in this class here? Like, should I put on here? And then the wheel event, and then how I'm gonna scale this? Like, should I change the dimensions and the width, like the width and the height here? Based on like, what is the parameter that I use? Like, there's several different questions that I don't know, like, how to answer. And then, like, should I access, like, a scale thing, or should I change the height and the width? How does the interaction manager is related to the app, and how that is related to the other elements? And I think that, like, just reading the documentation is not very clear to me. So, like, I want to have a better understanding of how everything's connected. But the issue with this is that, like, it might be... Because I always get into this, like, dilemma. Not sure how to say that, but... Because then I might spend like hours on top of hours just reading that, because there's 20,000 lines, I think, of code in that page, and then I'm gonna have to spend a bunch of time like reading everything, trying to understand, and then it might be a waste of time. It just might be better to just try a bunch of different stuff and see what works. But then if I build, like, just try a bunch of different stuff and it works, then I might be building everything on a shitty foundation, and then later on I might regret a lot that, because then I have to rebuild everything. But just reading this stuff here is not very clear to me. It's also because I'm using like the wrapper on top of this, which is this documentation here, and this doesn't talk about the events that much. And then there's also the Matter mouse constraints and the mouse, and I'm not really sure how this library is going to interact with React-pixi, and how React-pixi is handling the state under the hood and the context, and how, like, what is the best approach to deal with the events. Because I imagine, like, this is the issue that I have right now, is if I put everything here inside of the user fact, I imagine that I'm going to have a bunch of different events, so it might be better to extrapolate this into like abstract away into a class and put it in another file, and just call like event manager or something like that, and then I initialize the class inside of the user fact, and then I bind a bunch of events to the... I just pass the interaction manager or the app, and then bind a bunch of events on the app, on the class, on the initialization, and then I decide inside of the class what's gonna happen based on each event. But it's very hard to decide. I feel like I always struggle with this. It's really hard to think about, because a lot of the times I don't know if I'm wasting a bunch of time just trying to understand everything before, because I know I have the tendency of, I'm more of a person of being paralysis by analysis. So I have the tendency of being trying to understand too much, because I don't want to rely on the libraries. I think that's one of the things that, like, subconsciously I'm trying to avoid putting a bunch of extra libraries, because I know that as it scales, it has more libraries and then has more points of failure. So as it gets more complex, then like everything is working one day, and then like at some point something breaks or a version changes and something like that, and then like everything else collapses. And if I don't have the understanding, then it becomes really hard to like figure out what's wrong. But then if I don't, like, you have to rely on all these libraries, because then, like, if you don't, you're just gonna lose because you're not fast enough to build things. And obviously everything is gonna be like integrated with everything else, so like it's impossible for one person to know everything. Unless you're an artificial intelligence and you have you can process the whole data set of humanity and learn everything like in a few hours. But even then, I think like you're not really. I think that AGI is not gonna be one single agent. It's always like a collection of agents that at some level of perception it seems like it is a unity, but it's made out of everything else. So here, like the example that ChatGPT is giving me, I think is not correct for what I'm trying to do. And I also think that's maybe off with this thing here. Let's see if yeah. That's the problem. I have to wait for the... That's another issue, is the rendering cycle of Next.js. That I'm not really sure when it's gonna set the app here. You can try to use app instead of this one, but I think that hook is more for child components, not for the component you're creating the stage. It'll be fine. Yes, yeah. Yeah, that's the problem. Let me see if this works on the child. I think it's gonna work. Probably I'm using this on the other ones. Yeah, I'm using here. So on this component it doesn't work because that's the one that I'm setting up the stage. But it feels like I should be setting up the event listener on this one as well. So maybe I create a ref for this one instead. But then it's the whole thing that I'm gonna have to figure out a way to wait for this. Current's undefined. And then it loads. I always forget that I'm doing the server now on this one. So I guess I can put if statement, then if the current exists, I put the event listener. But I'm not sure if that's how I should do it. It's the best way to do it. So let me think. What should I do? The main things that I want to accomplish is setting up the zone. I'm gonna start with this one. I need to set up the zone, and then I need to fix the edges. I think that those are the main things. Then after that, it's think about how to customize and how to change other events. Add and remove other events. I think I'm gonna look at these examples, and then I'm probably gonna search. I think it's probably just worth it to spend a lot of time searching or studying the source code so I understand more how it works. But not sure if that's a waste of time or not. The other thing I was thinking about is whether or not I should just use because like in the documentation they say that the imperative way, not sure if it's imperative or declarative, but the way that you write the actual classes is faster than doing with the library. But so I was thinking about like, should I do it? Should I try to do it? Because it's also easier if you just write everything inside of the classes and it's faster. So because it's not that it's easier because you have to write more code, but it's easier to understand what is going on because you are the one that is actually writing everything. So it's contemplated whether or not I should create just like stop using the library and just create a bunch of classes or functions that create the classes, and then just use this version, this version here, and then just build whatever I need, and then like create the classes on initialize the class instead of the use effect, and then append the container instead of doing the like using the components from the Pixi, React-pixi. Maybe I should set up the events inside of the mouse component instead of setting up here. Maybe that's a better way. Or in the world component. I think I'm just gonna delete this stuff. It's probably not the best. I think it makes more sense. It's either on the mouse or the world component to put the events. Probably on the mouse makes more sense. But then I like wonder about the other events. And I tried to change this one, but it doesn't work. I have to use the use sticker thing. Use stick, or yeah, use stick. And then I change there. I'm gonna move this component to the top there. Yeah, I think here makes more sense. So I think I have the best way is probably to do here, accessing the app. Then I either put an event, I have to see, either had access the app interactivity thing here and then add the event there. Or I have to add on the engine here, the Matter, or both. I think that's probably the correct way to do it. Or the best way to do it. I think I'm gonna remove this, see if changes anything. Yeah, nice. I think I'm gonna roll on the RNG, to be honest. Like, randomize this decision. Whether or not to study the source code or to try a bunch of different stuff. Just see what works. I think I'm gonna go make more coffee. So I'm gonna put 50-50 on the RNG and then whatever I get, I'm gonna do. Maybe we should roll like 3 different RNGs. Because I don't think that it matters that much, like which routes, because I probably should do both. It's just a matter of hierarchy of priorities. Because, like, obviously I'm planning to do this for a long time, to improve this a bunch. Like, I want to improve it as much until I get to the point where, like, I'm using this all the time myself, because it's that useful to understand how code works. I think that that's what I want to build this up to. So I'm gonna have to understand this anyway eventually, like how, like, I'm gonna have to gradually increase my understanding over time. So it's more about like in relationship to the build space stuff because of the demo day. Well, which thing should I do first? I think that's like why it's hard to decide. But I think both of the things are important. So like I have to make the stuff better fast because of the build space, but at the same time I have to understand, like, increase my intuition over how everything is connected. And like what is the best way to create stuff on top of the things that I already have, so that's based on the whole direction that I'm trying to go, how it's gonna work, like which way is gonna be better to scale. I think once I add customizations and different types of visualization, what is the best way to structure the event listeners and the components and the functions that are gonna organize the data flow between the server and the client, so that later on, like, I don't have to spend a bunch of time refactoring stuff because I realize that there's something that I didn't think about and that changes everything. So I'm gonna do 50-50. I'm gonna randomize this and I'm gonna go make some coffee, more coffee, and then I'm gonna, whatever I fall, I'm gonna do. I think 50 or less, I'm gonna study. Study the source code. More. Try different stuff. Let's see how it changes visualization. I'm gonna roll 3 different RNGs. I think I'll roll 2 before I do the coffee and then 1 after. I'm probably gonna do both of these things today. Just gonna spend some time at first doing one of them, whichever I get on the RNG, and then the rest of the time doing the other one. I usually do an average, then that's a lot of ads. $31 plus. This one is I'll do the average of all of them. Obviously it's gonna go closer to 50 the more times you roll, but I'm gonna go make some coffee, then I roll this one after. So I'll be right back. Here's a giant cricket on the, don't know how to say that in English. I think it's curtain or whatever. And so let's roll this. I think I kind of want to study the source code, to be honest, because I think there isn't, and luckily I was gonna fall into that. But like the thing is that it's really cool to see the cricket. The thing is, with this approach, the reason why I think I don't like that much is because like it feels like you're using more force than power. You're just trying to bang your head against the wall like multiple different times until you figure out what works. And even if if works is like there's no way for you to know if it is the best approach or not. So like that's the reason why I don't like that approach that much. Even if I make the thing happen, then I'm not really sure if like what I'm doing is the best approach or not, because I don't understand the design and how everything is connected. So I think yeah, that's why I gravitate more towards the other approach. Because once you understand how everything works, then it becomes much easier to build. It's slower at first, but then like it becomes a lot faster in the long term. But a lot of the times it's obviously not clear. So yeah. So let's study the source code. I don't think the camera goes that far, but yeah. Like it's very interesting to me. I like animals and insects, that kind of stuff. It's like watching aliens. We take it for granted because we are accustomed to it, let's say. Like it's normal for us, but like if you think about it, every animal and every insect is kind of like an alien. It's very interesting to observe. I'm gonna see if I can. I need to take some time to figure out what are the best piano music for this kind of thing, for coding. Because there are ones that I really like, but then like I don't remember their names. Or in the playlist that I have, it's just like it's not all of them that I enjoy listening to while I code. Really interesting. I don't know why they do it like this. There must be some convention or something that I don't understand. And why put the name as this $sign tree? Maybe it's because there are other stuff that they wanna name as this thing here, so they change the name to the other, so it doesn't have any conflict. But so I think the main thing that I want to understand here is like what is the mentality of the design of this library, the React-pixi. Like, how can I picture what is going on in the components under the hood with the actual application, so I understand how to do everything that I want there. I also need to improve the way that I think about the rendering cycle in the Next.js, because I don't like, even though I study a lot already and I understand the concepts, I don't really understand like mainly this thing about the use effect, like why sometimes it works and when getting the references or doing stuff inside of the use effect, when pressing props. So it's like the whole design of the thing, the tree, and the way that the tree updates, and the relationship between virtual DOM and real DOM, and the diffing algorithm. Also the webpack configurations and that kind of thing. I don't understand well enough, I think. Even though like I know the basics, but not it's not intuitive to me. Like, I feel like those kinds of things I should, whenever there's a problem with the rendering on use effect when I'm passing something as a prop, I should know like intuitively why. And I think I do know is because of the relationship between rendering in the server side and the client side, but I don't know enough on the source code or under the hood what's happening. It kind of annoys me. Let's see here. So it's like a bunch of objects with the key, with the cycles, and the value is the function. I think that this library is kind of old, maybe. So it's more, it's like was designed for the class components. I think there's another one. Oh. Let me see if there are two of them. I'm waiting for them to leave so I can close a little bit because there's too much sun. Too much reflection on the monitors. Right back. So I guess this stage function is the component. It's pretty much, I don't understand why they did things like this. And it's probably just so they can use functions instead of classes. But I don't understand really well like everything that is going on, but I assume that they are creating a constructor, a super constructor, so like this function is inheriting from a React component, and then it's passing the arguments here and it's defining the properties of this to be no, like this is the value, this is the property, and then the this here would be the this from the constructor, from the super. A super call apply super. It's concatenating the arguments from the super class here, which is the React component, with the arguments for this one, for this function here. But I don't understand why I do things this way. And I'm also trying to understand how, like, I assume that when you create the component stage, you're calling this function here, but I don't understand how that happens. Maybe it's just like the component itself is the function, but I think I need to like go back and like study again how it works when you're creating a React component. Like you're just creating an object, but I don't remember the details really well. I think that's the main thing that I need to clarify more, is the connection between the standard JavaScript and the way that React works with the JSX syntax, and how they are connected through the compiler. Because in my mind, I like viewed them as two different things. It's kind of hard for me to think about a normal JavaScript function in the same way that I think about React component, because obviously the React component is done with the JSX, so you return HTML elements. But like, how do you translate a normal JavaScript function into a React component? I think that's the reason why, like, I don't understand really well here how it works. And then I assume that like this is it's like creating a class. Like all of this stuff here is pretty much just creating a class of stage and extending the React component, and then creating the functions for the cycles here. But instead of having the function component did mount, you have this key value pair, or this key that says what the function is going to be, and then like the value is the function. And then those things here handle this life cycle of the component. But I don't understand why do it this way instead of just putting the classes. Maybe it's for like performance reasons, or because the library is older and then they just update it through time without like making huge differences in syntax. And I guess that this is from the Pixi. This is the class from Pixi. Like, what makes this annoying is that it makes it much harder to understand what's going on, because there's all these functions here connected, so just have to go back and forth. Like, a lot of the times I don't know if I don't like the way that these things are, because I don't have a lot of experience. Like, I haven't studied a lot of different libraries, source code, or have experience building libraries. But a lot of the times the feeling that I get when I'm looking through the source code of these libraries usually is that it feels like it's overcomplicated, but it might be because I lack experience. That's the thing. So it's very hard to know Like if I think it's complicated because overcomplicated because I don't have experience writing code in this way, or it's because people tend to make things overcomplicated because like human beings are not scalable. So usually when things grow a lot, it becomes hard because like one person starts doing the thing with like their own style, and then other people go with their style, and then like it kind of compounds itself. And then like it becomes like more complicated rather than complex, let's say. There's gonna be complex anyway because there's so much stuff, but complication is when like there's unnecessary complexity that is added. But I think it's very possible that it's probably because of lack of experience, because it's the same feeling that I get with TypeScript, but like I think most people agree that it is better, so it's probably lack of experience from my part. It feels like just unnecessary stuff that just like adds a bunch of like baggage to everything. So it's either the argument or an empty object. Let's see. Design as empty object. Don't understand this thing. Okay, I think I intuitively understand what is going on, but it's very hard to know for sure looking at the code, because I don't know what a lot of these functions do. It's just checking the properties of the object that it passes through the function. And like this, the name is very descriptive, so just spreading the object. But I don't understand really well how it works, or why you do this. I think it's more likely that it looks complicated to me because I don't understand well enough the fundamentals. So I think, yeah, it's probably better to. I think I'm starting to understand a little bit more, but it's gonna take a lot of time. But I think a good idea is to search for the interaction thing, see if there's anything on the file that is related to that. But I think the way that it works is pretty much like they are emulating classes with functions, and then they created a bunch of functions that allows them to use these built-in object functions from JavaScript to like simulate the inheritance of classes using the prototype chain. And then based on that, they are like simulating the creation of classes with functions, and then they extend the React component to the functions. And then when you import in the files, you're importing, so like each one of these is a function there, the ones that I was looking at. And then when you create the component, it like triggers the function, it runs. So I have to clarify more how. Maybe I should put some of the source code in ChatGPT and try to make it explain. Because, yeah, I think that's the thing that I have to do, is understand more how each of these functions work. Because I'm having trouble trying to understand how, like, when you create the component, what is happening under the hood. Is it running the function? And then if the answer is yes, then what is happening? I think what is happening is just creating the constructor and putting the attributes and just running the code of the function. But I don't understand really well how the final React component is going to look like, and then how it's going to be related to everything else. But I think that I should probably search for the interaction thing, see if there's anything related to that, and then try to break down the stage component there, the stage function, get each one of those functions and try to see if I understand what's going on. The main thing that I want to try to understand is what is the final component gonna look like when you put there. How are the children related to that function? And then like how can I use that to, and where, I think mainly where should I put the event listeners, and how those functions are going to be related to the Matter engine. Because that's the thing that makes it difficult, I think. More difficult is that I'm rendering as a child the components that are related to Matter JS, which are the components that I created there. They have the Matter JS functions that create the engines. So I'm wrapping the whole application. Like the children of the application are going to be related to the Matter JS engine. And then I need to understand the flow of communication between the Matter JS and the Pixi component under the hood. So I understand like how to put the event listeners so that it changes the components in the way that I want. And what is the best way to do that? To structure the event listeners. So both have to study this one, understand more, and I have to understand. So I think mainly how are the children's rendered from the main stage components. How is the engine and mouse are I think those are the main things that I want to understand. And I've seen there that it uses the reconciliation, and I think that the React reconciliation is the low-level function that allows you to change the update cycle, which is the communication between the virtual DOM and the real DOM. So there's probably something related to that, because I saw that there's something talking about the React reconciler on the file, but I don't understand obviously yet how it works. So I think there isn't anything specifically related to that library. See the imports there. It's got the display, the app, the ticker. So it is related to the interaction through the app application. Loader, ticker, and renderer. So I think I have to change. So probably on the React-pixi there isn't, since I couldn't find there, they don't implement the interaction directly. So they implement this application which has this other stuff. So I probably have to access the renderer through this use app hook inside of the mouse thing. Then once I access the renderer, I'm gonna do that inside of the event probably. So I created in the interaction. But that's the thing that I'm not really sure, like, because I'm gonna have to create this interaction class from outside of the React-pixi because it's not implemented there. So I create like this class, an instance of this class, and then through this instance inside of the events that I create to this instance, maybe I pass the renderer through the instance of the interaction. That's how I connect them both. And then inside of that, I change the size of the renderer. So I have to understand how the renderer creates the scale and how that is related to the elements. run the... Yeah, the way they talk about here, like, this is the thing that is kind of confusing, because then, like, it seems that this interaction is more for each element of the thing. So, like, it's not related to the zoom events, because the zoom is more about the camera, and this is more about each element inside of the scene. So to use this, what I have to do probably is, inside of the use effect, make the interactive equals true for each thing that I create there. But then it's just for adding events for the actual visualization. But I'm already using Matter JS for those kinds of things. So, you know, like, it looks like this is not more... You shouldn't use this for the zoom events, but maybe I'm wrong. This is not very clear here. So I have to clarify if I should do it through the Matter JS or through Pixi, or maybe neither. Maybe just added the, like, get the element using the reference and then add the event directly to the element itself, which is the canvas or the stage. So the way that I was doing there before. But that's, it seems like it's not the correct approach, because then, like, the whole library handles the animation of everything. So I think that if I put the event using the reference, it's not going to be good, because then even if it works, it's not zooming in and out. When it zooms in and out, it's not going to change the visualization. I need to clarify this more to understand. Like it's creating the super based on this, which should be a React component, but it's confusing because I don't know like where is this being called. So I'm gonna look into this first and then I'll go back to this one. So I have to understand these plugins more. trying to see if I can find the renderer code, because it looks like this is the stuff that has the plugins. So I want to understand more how the plugins work, because this has to do with the interaction. So I think I have to access this, and then through this I put the event. And I still have the question of whether to use Matter JS or Pixi, and at what level should I put the event to zoom, and if I should create something that propagates the events, like they say they're like bubbling, where when you zoom it's gonna affect all of the components that are childs of the parent where I put the event, because that's obviously gonna change the way that I put the function, where I put the function, which components, and how I think about how to customize the graph or build everything else. So I need to find this app renderer. I think this is the stuff that I was searching for before. I didn't realize, confused the two, that I was looking at the guides there. So like this is the official documentation. I remember looking at this page sometimes, that's why I was like I forgot that the other one was the guides and not the documentation. I think you should probably change the way that I'm doing the resizing there as well. Instead of putting the event on the window like I'm doing here, I think I should probably put it on the container there, the main container. Yeah, I'm adding the resize to the window. So I should probably put on this container and the other one, or like on the world. What is the simplest way though? Okay, I think I know what to do already, but it's hard to decide. Like, what is the best way to go about it? How to think about the connection between Matter JS and Pixi? So I think I need to think about the set of questions that I have to clarify what I'm thinking about, and then based on these questions, once I understand, then I implement this stuff. Let me see how this thing is being created. So it creates the states, uses the states to create the engine based on the matter, and then uses the hook from the React-pixi to update the engine based on the FPS or I forgot how to say it, but the refresh rates of the monitor, I think, which is 60 frames per second. Yeah, frames per second. So the use stick comes from Pixi, and then I think this is created once you create the stage, which creates the application. So let me see. Let me think about this. So application. And use stick cross nation. Right. Like, what I'm gonna do is just go through the source code here, and I'm gonna, like, based on the stuff that I have here, I'm gonna create a sequence of things that I have to clarify to understand the system better in my mind. And then based on that, I'm gonna get all of the functions that I don't understand, use ChatGPT to understand more how it works. The low level functions from JavaScript and how they are used there to create the chain of prototypes. And then, yeah, I need to think about, like, what kind of questions I have to ask to clarify more how it works, so I understand the flow of the information in the way that's in the code, in the way that I'm writing here, and how it creates everything. So it first wraps everything on the stage, then it creates this world that is a child of the stage. The world is updated based on the tick, which is the frame cycle, the animation cycle from this stage, which is this use tick here, and it updates the engine calling this function. And this wraps the mouse, which uses the app. So use app is the context of the app that is created in this file here, I think, as well. So this uses the app and the engine. So it creates an instance of the mouse object or method from the Matter class using passing the view from the app. So let me go back and look. What is the view? I think probably here as well. If I go back, probably can find. Just gonna read the description for now. Oh, here it doesn't have the view. Maybe its own application and then view. Yeah, view. So passes the canvas to the mouse there. I see Matter mouse creates a mouse input. New mouse, yeah. So it has the mouse here, and it creates a constraint, passing the engine and the constraint. Allowing user interaction, providing the ability to move bodies via the mouse or touch. Creates a new mouse constraint. All properties have default values. Many are pre-calculated automatically based on other properties. So I think this is more related to the elements. So there's probably two different types of approach. I think the reason why the example is using Matter JS is because it's doing the calculations and everything else with the physics engine from Matter JS, so it makes more sense to put the interactions of the elements with the, like, delegate that to Matter JS instead of using the interaction from Pixi. Which I think it makes a lot of sense. So, like, this mouse thing handles the interaction with the elements here, which is the click and drag events. But then the question is, maybe I can't even do... Yeah, I think it doesn't make any sense to do things related to the view with Matter JS, because Matter JS is more about the interactivity and the calculations of how the objects are going to move and interact with each other, because it is the physics engine. So it makes a lot more sense in my mind to delegate the events of the screen and how the objects are displayed to the Pixi interaction thing, and then everything else delegate the elements to the Matter.js. But obviously they are correlated, and that's why it's confusing, because if I'm updating the view based on the interaction from Pixi, then how that's going to be related to the mouse. I think that's one of the things that I have to clarify. What is this scale here? So let's see. It's passing the instance of the mouse that it creates through the view. So like it's creating a mouse object based on the canvas from the app view, which is the instance of the stage. And then it uses that scale to get the scale for the mouse. That's the mouse position scale. Yeah, so this doesn't have anything to do. Like, it's just setting the scale. Yeah, but then, like, I'm gonna have to change the scale as well. If I change the scale of the whole app. But maybe not. Because maybe it changes based on this. Because it's already attached to the canvas. So if I change the scale of the view, does it automatically change the scale of the mouse object from Matter JS? But I think that's just easier, like, to test than to look at the source code. But I'm gonna write the questions that I have. So, like, I want to clarify a sequence of things that I can search, that I can look at in the source code. So I clarify everything, and then after I clarify, it's gonna be much easier to figure out at what point I have to create everything and how to, like, create more stuff to interact with the things that I already have. But right now I'm thinking that's probably better to get the instance of the app in the world here, and then through this add the events based on the plugins of that are gonna be, that I'm gonna access the interaction. So app.view.plugins.interaction by using the use app here, and then through that I put the event listeners on this world component for the zoom and for moving the scene around. And that is probably gonna automatically change this one, but I'm not really sure about it as well, because I think it changes because I'm changing the context. So, like, this scale is always gonna be this one, which is the, like, 1 divided by the pixel ratio of the screen. So this is always like 1 by 1, let's say, scale. And then the view just changes the absolute scale of the thing. But for this one, it has to be 1 by 1. Because each tick is updating the engine. This is both gonna update the view and the engine. Like, it first updates the view, which triggers the update of the engine, I think. So how is application instance related to use it? How does the stage function renders the chat components? So I think the main thing I have to understand is how the function there, the stage function, becomes the component. then I think most likely what I'm gonna do is access the context here on the world and then add the events based on the whatever I find in documentation, the way like how I should do it here through these classes. Just gonna see, because I have access to this application and I have access to this, so it's probably through this thing here, through the plugins, like renderer and the plugins, and then accessing the interaction thing there, and then through that I add the event listeners on there, and all of the other events is probably better to do it through the Matter JS thing, and then I have to clarify how connection between Matter JS events and Pixi React Canvas events. I think so those are the big things. First, understand better how the stage works, then how Matter JS is connected to Pixi React. How the view changes the calculations of the positions of everything on Matter JS. I think then probably the best is to handle everything related to the view itself through Pixi, and handle the events of the interaction of the nodes and the edges through Matter JS. Because eventually what I want to do is be able, which is the stuff that I talked about a long time ago, is be able to move through the graph using the keyboard, move through the nodes. And that's the other thing, because their Matter JS is just for the mouse. So I have to see if I'm able, because I'm probably gonna have to do the mouse events through the keyboard events through the Pixi thing. So that's another challenge. But I would like to do is move through the nodes with the mouse, with the keyboard, and then also add the ability to, but that's going to be very difficult to do. Like I think it's it's a lot easier if it is on the local computer, to be able to click on the nodes or to press enter, let's say, on the selected node through the keyboard. And then once you do that, it goes to the point of the code that you're at. So let's say you're navigating through the graph and you're like on a function or a local variable or something like that. It would be nice to just be able to press enter, and then it shows on your computer in your IDE where the function is located. And also the other thing that I'm thinking about is being able to add animations as well. So like simulate how it would look like in real time, and then bind that to keyboard events as well. So let's say you press play, then you would show like you would highlight the edges and the nodes, changing color as the function or as the script executes, and also like do visualizations for the data flow for the execution of the script, so you can see like in real time what's happening. I think that would help a lot, but then I have to think about how I'm gonna structure that, because it's both keyboard events and the animations. And I think to do the animations, I'm gonna use the use stick here. That's probably the way to do it. And then there are other stuff there on the examples that show like how to animate, but like the challenge is connecting all of this stuff and figuring out, because like I'm gonna have to compartmentalize, let's say, like put some of this stuff on other files with other classes or functions, and then how I'm gonna relate that to the components that I have here. But maybe I create different pages for that on the app. That's another option. This is another, so this is probably the way to do it. Just put Matter events instead of the components themselves, the particles here and the edges. Just use the context from the engine, and I put the demo instead of the use effect here probably after creating or adding to the world. But maybe you don't need a... I have to create another variable probably. Or just do Matter events and then and pass the body current as the argument here on the object. Then pass the event name, which is gonna... I have to look it up, which is gonna be like a keyboard event, and then I put whatever function I need there. But the challenge is gonna be because, yeah, I'm not really sure if it's gonna be possible to do that, because like the way that I'm gonna do it, if it's possible, is to, or if it's not too complicated, is to send the data, like on the callback function, to send the data back to the server. Like send the properties of the specific node to the server, and then on the server side use the sys library or other library to get the position, like get the line, the file and stuff like that from the, or whatever thing I want to do. But then I would have to figure out how to use the serverless function inside of Next.js to get access to the local computer for on the client side, and use that information to try to find the file, the computer of the person. Then it gets like very complicated because there's a lot of different operational systems and browsers and stuff like that, so it's very annoying. Yeah, so on the creation I put the on event, and then on the components itself I put the on click event. Maybe. I'm not really sure. So let me think. Like this is another thing that's difficult, is that I'm receiving the size and the width as props, because I want to resize based on the parent component, the div that is wrapping the application, or the component, the nodes component. So it's difficult because even though I can access the app through the context inside of the world there, then like how do I resize? I can accept as props the width and height. Maybe I'll do that. But then like it's tricky because of the reference, like the rendering cycle, I think, of Next.js. Because I'm passing from the ref of the parent component inside of there, then I pass as props in the world. So like here, I'm receiving as props, and then I would pass this to this component here, the offset width and height. And then inside of here, I create a use effect event here. And then on the use effect, I use the app context to put this resize to, and then just pass as props, or like yeah, but that wouldn't. I have to bind an event listener to the thing, so I think that the resize true is not the correct function. Like I would have to find which element to. Yeah, I think I need to get the app context, then connect figure out how to access the interaction, and then through the interaction I bind the event listener for resizing. Then inside of the function I put the resize true from the app, and then I pass the width and height that I'm receiving as props. I think that's probably the way you should do it. And then hopefully that would resize everything else that is inside, because the component is wrapping the other ones. Like I'm resizing the whole application, so resizes everything else by default, maybe. The other way is to get the reference for the stage, like create a ref here, and then just put the event listener on this one through the ref, like ref on resize. But instead of putting the window here, I put the ref here. But I think that's not the best way. I think the way is probably to access the interaction through the app context, then add the event listener through the interactions, put resize, and then call the function here on the application. Yeah, this. Or maybe just pass this as props there through the options. Yeah, I should. Maybe that's the best way, and the easiest way. Just pass, put as option there, and then resize through, and then pass the stuff as props. That's automatically gonna resize stage, yeah. And then this is gonna be an object probably. Oh, but that's the thing, because maybe just pass props.current. I think you have to pass the element. Let's comment this stuff out. So let's see. Now let's do this. It's still not... yeah. It still doesn't update the elements there. Or maybe it is updating the view though. That's the editor. Let's see. I think it is working, but you have to manually update the elements. This is a different thing. Yeah, I think this works, and it is the correct way to do it, so I'm just gonna delete the stuff that I have there. And then I have to see how to change that, which is a display thing. So it's probably gonna be similar, and there's a property there that is gonna allow me to resize. I think I am making progress in understanding the stuff. So I think I'm gonna spend. I think like I already have a good idea of how to implement everything, like how to make it work. If I test, like maybe I'm gonna fail a bunch of times in the beginning, but I'm confident that if I try enough stuff, I know how to make everything that I wanna make, like the event listeners. But I wanna understand a lot more how it works, like all the functions. So I think I'm gonna spend a lot more time studying everything there, so I understand really well how the source code works. And then only then I'm gonna implement everything. Like the thing here is that there must be a way, because the problem is if I put the resize to this container, maybe it works, but like here I have to initialize. Like this is the way that they say that you should do it on the Matter JS, like create 2 different or 4 different rectangles or squares around the view so that you create like boundaries. But I don't like this that much. Like it feels kind of wrong to me. There must be like a better approach, I think. An easier approach and more like that is better. Like I think maybe trying to create without the boundaries here, without this container, and then just putting the constraints inside of the shapes that I'm creating here, so that the movement is not like, and that way there would be no constraints on the view, but then because they are because of the gravity and the force between the nodes wouldn't fly away too far from each other, even though there is no constraints. So like here you have this constraint here, which is not updating now, and then if it passes the constraint, it just floats towards infinity because of the gravity. But I think that's the best way is probably to remove the boundaries, but then make it so that the nodes are always like connected, and then they don't float around too much from each other. And that way you would be able, like I would have a lot more, because the thing that I don't know how it's gonna work is when I add the zoom in and out effect. Like let's say I have like thousands of nodes here. Like on Vue.js, you can zoom in and out infinitely, and like you can also change the gravity, which changes the layout. And like it doesn't seem like it has the boundaries. I think that if I keep with the boundaries, then it might be very bad to visualize, even if you zoom out a lot, because it's always confined to the space of the boundaries. But maybe that's not the case, because then when you zoom in and out, you can zoom in and out the boundaries as well. So it is always the same, but because you're zooming in and out, even though you're always confined to the same space, it looks like you have a lot more space because you zoomed out. But I think that would make the visualization worse, I think, because of the way that the elements are, like the pixel ratio. At least intuitively, that's what I think was gonna happen. So probably the best approach is to figure out how to remove this container here and then make it so that like you have an infinite amount of space, but because the nodes are connected to each other, and there's some gravitational force, they don't deviate too much, like they don't go towards infinity here if you push each node, push or pull. I'm not sure if that's possible or not to do. I think I'm gonna go get something to eat now, and I'm gonna watch the videos from this playlist here. He builds one of the examples there, and I'm gonna eat something. And I'm probably gonna remove the camera, then just eat something while I watch these videos here, and then go back to studying the source code. I think I'm just gonna try to answer these questions here one by one. And then once I feel like I have a very good understanding of how everything is working there, then I start trying to implement the event listeners. So I'll be right back.
actually has an interface for manipulating a lot of these particular variables. So, I've been kind of in the code just changing numbers and refreshing. Obviously, building an interface to sort of tweak and test different values is much better, and this is built in right in the demo page. So what I'm going to do is essentially what I want to try to do is recreate exactly this chain by connecting a bunch of these circular bodies by constraints. And here's the thing. So I was looking at the Matter.js documentation, and it actually has something called composites. So composites are a composites module. It says right here contains factory methods for creating composite bodies. So this is what you could use actually. Oh, I just want to have a chain of things, or I want to have a stack of things. And there's even a composite for a car, which is really just like a couple shapes and some wheels maybe. But here's the thing. I'm going to do this video and make this tutorial without using the built-in composites. Certainly if what I want is a chain, using the built-in composite chain might make this easier, but I want to build this in a flexible way that I could kind of make anything. I could make a chain that has branches coming out of it. So I want to have total flexibility to see what happens if I individually create all of the particles and constraints one by one and attach them in a completely customizable way. Maybe this is a bad idea, but I'm going to give it a try. Okay, so what do I need to do? So the first thing, just to sort of work this out. So okay, this is my program currently. This is where I am. All it has is a single ground body. So it's the same ground body that I've had in previous videos. I also made a change from the previous videos where that circle object is now called particle. But I haven't put any particles into the world. I could, however, put one. So I could say var p equals a new particle, and I'm just going to make it at 200, 100 with a radius of 10. And then I could just say in draw p.show. Oh, it's actually pushing particles into an array. So what happened? P is not defined. Oh yeah, but I'm using that array. So let me say particles.push p, and then let me actually iterate over that array with my non-for each loop. And just say particles index i.show. So let me just get one thing. So there's my one particle. Now I want to add a second one. What I want to do is I'm going to make that p1, and I'm going to say p2 is 200, 150, and I'm going to push both of those into the array. So there's two of them. Now these have no relationship. They bounce off of each other and move apart. What I want to do is I want to use something in Matter.js, and this is the same idea. So it's called a constraint. I didn't spell that right. Constraint, like train is in there, I think, somewhere, right? Constraint. It's called that in Matter.js. But if I were in Box2D, this would be called a joint. If I were in ToxicLibs, it would be called a spring. So there's lots of other terms for the same thing. It's an entity that connects two bodies. Now it does not have any geometry. So the idea is if there are two particles, I want to be able to connect them with this thing called a constraint. But one thing to note about the constraint is it doesn't have geometry, so something will fall through it. So there are other scenarios where what you might want to do is make like a bridge, but it's sort of like a springy bridge, where what you could do is make a bunch of rectangular bodies that abut each other, and then you could actually connect them with constraints, but there's very little space between them. So that's another scenario that I could do in a coding challenge or something. But here, I just want to be able to attach these two bodies. Now, this is always much more complex than you think, because there's a lot of things I need to set. I need to say which two bodies? So body A and body B. But also I just say, where is the constraint attached? Is it at its center? Or I might want to do something like this, where I kind of connect them from the edges. So in Matter.js, I'm pretty sure it has a way of doing this. I think it's called point A and point B. So there's the bodies, and then the point is not the location of the constraint, but the offset of the constraint relative to maybe the center point of the body. Then I also need usually a property called like length, which is often the rest length. So if you think about a spring, if you pull on a spring, it starts to but eventually it comes to a rest. So what is this sort of resting point where there will be no force, either contracting or expanding it? So excuse me, the rest length. There's also, what else would there be? Maybe there's a kind of like strength option, like how is it very rigid, is it like a rubber band, that type of thing. So just to make this single thing that connects two bodies, I need to set a lot of parameters. So let's go try to do that. Over here, okay. So what I want to do is, now I want to try to make a constraint. So let's go look. Constraint, I have that page open. Matter.constraint module contains methods for creating and manipulating constraints. Constraints are used to specify fixed distance between two bodies, all the sorts of stiffness, springs, or elastic. So I think this is what I want. Matter.constraint.create. So I'm going to say, I'm going to just make a variable called options. Then I want to say matter.constraint.create. Now, what I could do here is say, I could add another alias, just constraint equals matter.constraint, right? I think that's what I want here. And then now I can just say, constraint.create. So var, I'm thinking here, var constraint equals. So now I'm just going to, that word constraint, the more you look at it, the more it looks like it's spelled wrong. I think it's right. I want to create a constraint, and with options. So create options. So I could certainly put the object with all the parameters right in here, but I just want to have a separate object where I keep track of it. So what are the options? See property section below for detailed information on what you can pass via the options object. Properties. Body A, body B, ID, label. These are probably things to keep track of. I don't need length. So these are things that I need. So let's look. So body A, I want to connect P1, that's the first one. Oh, but it's not P1, right? My particle is my own object. Particles, the body is the thing that Matter cares about. So P1's body to body B, P2's body. And then I also have point A, which is that offset, which I'm just going to make. Ooh, how do I set the offset? The offset is an object maybe with an X and a Y. So I'm going to just have that offset be an X and a Y of 0. It probably does that by default. So actually, let's just not put it in there. But if I wanted to offset it differently, I think I would put this in as an option. And then length is probably good. So let's do a length. Let's give that as like 50 pixels between them. And then what was the last one? Stiffness. 1 means the constraint is very stiff. 0.2 means it acts like a soft spring. So let's try that stiffness. Let's try like 0.34. So now, assuming what I then have to do is do world add world, constraint. So I've also got to tell the physics engine to put that constraint in the world. So now I've created a constraint between those two bodies with a specific rest length and a stiffness. I created it and I put it in the world. So now let's run it. Oops, constraint. Oh, because it is spelled wrong. The more you look at it, the more it becomes spelled wrong because I spelled it wrong. Constraint. Yeah, that's why it's spelled wrong. So let's see. Look at that. Whoa. So you can see that constraint. Now let's offset it a little bit so we can maybe see more what's going on. There we go. So you can kind of get the feeling like they're constrained together. Now the thing is, I can't see anything, but I could draw a line between them. So now in draw, I could do something like line. This is a terrible way to do it. Particles 0 dot body dot position. Oh, this is like the worst thing I could ever possibly do. Right? Draw a line between this first one's x and y. Whoops. And the second one's x and y. And let's see what we got here. Now I've got a line, so you can sort of see. Now it sort of feels more like it's working. So this is the whole thing. Again, I can't say this enough about physics engines. There's the actual physics, and then there's what you're drawing. Mostly you want those things to match, but sometimes maybe you want to not reveal what's connecting what, or maybe you want to draw that in a different way. So there's a lot of possibilities how you think about this. So now here's the thing. What I actually want to do is create a chain of these. So there's a bunch of different ways we could think about approaching this, but let's just build with what we have. So first of all, this idea of creating two separate particles and pushing them and then creating this constraint here, I need a kind of loop to do this. And again, I could use the built-in Matter.js composites, but I'm gonna be stubborn here and do this in my own way. So I'm gonna say var. Let's think of it as going. Let's actually have it go horizontally. So let's start as an x at like 20 pixels. Let's have x go all the way to the width minus 20, which is like 380, and then I'm gonna go every 20 pixels. So every 20 pixels, and I'm gonna comment a lot of this stuff out. I want to create a particle at x, 100. So I want to put a row of particles across. There we go. Now, ignore the fact that that line is drawn there. There's no, I'm going to, where is that line drawn? Let's take that out, comment that out. And that's a lot of stuff. Let's move every 40 pixels. Okay, great. So we can see here, there's a whole bunch of things. Now, we're not really, there's not a lot of interplay here because they're all perfectly falling. So it's almost like there is a constraint. But let's change this now. So what do I want to do? I want to also make a constraint. And what I want is for, I want to say var p, and then I want to say var previous equals particles. Oh, let's create a variable before the loop called previous, and it's going to be equal to null. Then after I create that particle and in theory create the constraint, I'm going to say previous is equal to p. So what I want to do is I want to connect each particles with the previous one. That's all I want to do. So every time I go through this loop, make a particle, add it, and connect it to the previous one. However, I don't want to do that for the first one, right? So I do want to say only do this if previous exists. So only make this constraint if previous exists. So now if I were to do that, we can see, look at this, it's kind of, you can see, oh, they're definitely connected. There's a constraint, and they're all like moving along. That's cool. Now, so that's pretty good. Now here's the thing. What if I were to allow one of them to be static? So I could say, I could add an static's is a keyword in JavaScript. So what's another word I could use for static? Fixed. So I'm going to say is static fixed. So I could pass in, I could say here, like, if there's no previous, make, let's see, I'm trying to think of like, I just want the first one, this is kind of, I'm doing this, there's a nicer way to do this, I'm sure. But let's just say fixed equals false. So I'm going to pass in, none of them are fixed. But if not previous, then fixed equals true. So I'm just going to make the first one. If there's no previous, then I want it to be fixed. So if I do this, whoops, I got an error on particle.js line number 5, which is, there needs to be a comma here because I added another property. And there we go. So you can see that first one is fixed. So what I also want to do is now I'm just going to kind of change where they are. I'm going to start this one in, I'm going to start it more in the center, and maybe I'll add more of them, but I'll make them smaller and do something like this. So you can see, whoa, and maybe that rest length should actually be something more like 20. And there we go. So now you can see there's what I was kind of looking to do. I created this idea of a chain that are all connected. And if I made it much longer, like if I went all the way up to 600 to add even more, right, you're going to see it's going to kind of even, it's going to collide with the ground and kind of stop there. That's sort of weird. Oh, you know what? It went through the bottom because it's around the bottom because the bottom doesn't extend past the screen. So anyway, this could be obviously fixed in a lot of ways, but let's just leave it at this. So this is what I was attempting to do. Now here's the thing. There's a lot of improvements that I could make for this potentially. Number one is, I've kind of got a lot of code just in the weeds here in the main program. So in the same way that I had this idea of encapsulating this idea of a Matter.js particle, a body, into an object that keeps track of its own body and other things, I could now make a chain object. And a chain is an object that keeps track of an array of particles and those constraints. Also, the way that I'm creating these constraints, the same way I wrapped a body into a particle, I could wrap a constraint into a spring, so I could write my own show function, so I could draw lines between those things. That might be a bit more interesting. And so, because maybe what I actually want to do is render this in a different way. So there's a lot of possible ways, but this hopefully gives you the basic idea. Now, the thing that I want to add in the next video is how can I actually click on this and drag it around? So, the other thing that I might think about doing is what if I were to connect them from the left to the right and then make it a kind of bridge that things fall in and kind of rest on. So that would be another thing to maybe try. Play with the spring guys. So many things we could try here. So hopefully this showed you how constraints work in Matter.js to give you a basic idea of what you could do. And in the next video, I'm going to add a mouse constraint. See you there. Hello, welcome to the first video in a playlist about physics engines. Now, strangely enough, this video that I'm making right now, that you are watching, because somehow you are, is made in 2017. But the next videos that follow in this playlist were made several years ago, and those videos cover two specific physics engines, Box2D and ToxicLibs. So what I want to do in this video is kind of make a little update to what's the state of physics engines today, what are physics engines, what are some example physics engines that you might be interested in, what are some of the features of them, how they work, and then if you are keep being interested, you can continue and watch some more specific tutorials. At the very end of this playlist, you'll find some new updated physics engine tutorials with some newer physics engines I only started recently looking at, most notably a JavaScript one that was in the browser called Matter JS. This is an example of a processing sketch, a computer program, drawing graphics to the screen and using a physics engine behind the scenes to figure out when do things collide, what do they do after they collide, all the motion and animation, the location, position, velocity, angle, all of the stuff that's telling me what to draw in this physics engine. That makes no sense whatsoever. Let me try to make this make sense. Okay, so if you've watched any of my previous tutorial videos, one of the many programming tutorials, this is the thing that I do. I have a variable that's writing code in JavaScript. I have a variable called x maybe. And then somewhere in an animation loop, like a draw function in T5.js, I might say something like x equals x plus 1. And what that gives you is, if I want to draw something at that particular x location, maybe at a y location of 100, if I increment its location every frame, it's going to start to move. This, in a way, is a physics engine. What's the world of physics? It's a very simplistic world. Things can only move at a constant velocity on one dimension by one unit every moment of time. But ultimately, this is a physics engine. Now, if you follow some of my other tutorials, I start to add in a lot more things, like a y. And maybe I start using a concept called a vector, whether it's a p vector in processing or a p5 vector. And then I'll start to have things like, oh, there's a position, and there's a velocity, and there's an acceleration, and there's a force. And so, and then acceleration goes to velocity, velocity goes to position. All of this kind of stuff to formalize and encode a framework, a system for how things move around a computer screen, modeled off of the way things generally pretty much move in the real world. Lots of scientific caveats aside. So this is the trajectory that you'll find if you go back and watch a lot of my nature code video tutorials or even a lot of coding challenges where I'm moving and animating things in a computer graphics window. Now, what if someday, this will get me pretty far, and it's actually a really nice way to work because I have total control to invent my own creative take on physics and different kind of behaviors and creatures that have thoughts and desires and all sorts of things. It leads you to do a lot of exciting interesting things. But there are moments where you might think to yourself, oh, this vector math, and now I got to do collision, and suddenly, I want to know what happens when this strange polygon collides with this circle and does it bounce off this way. You start to go down this road, and suddenly you're spending years of your life developing these very elaborate, sophisticated algorithms to figure out how to make things move based on physics. And these are not new problems. And so there are library frameworks that you can import into your code to eliminate the need for you to write the lines of code where you add velocity to position or add acceleration to velocity. And all you do, the way that a physics engine generally works, is you can think of this as the physics engine. It's a box. And in some ways, it's a black box. You don't have to know how it works inside to make use of it, although it's kind of hard to just use one without some of this basic sensibility and having done some of this yourself to understand about forces and vectors and all that kind of thing, because these concepts are all embedded in physics engine. But if you have this black box, you have a moment writing in your program, the camera's over here, but I'm over here, you see? There's a moment where you have your program starts, and you say, hey, world of the thing that I'm making, I would like you to have some circles floating at the top of the screen, and then maybe a rectangle at the bottom, and then you have this little spinning wheel, and then I'm just going to say go. So the idea with physics engine is that you have this kind of setup where you tell the world what should be in it. So in setup, you might say, here's what I imagine the world to be. It starts with one of the coding challenges I would do that in a future video is Blinko. So I want to have a bunch of static knobs in the window, and then I want you to have a thing that's at the top, and then I want to have some buckets at the bottom. This is a weird example, okay? So it's all about instead of saying, here's what's going to be in the world. Then you tell the physics engine, here's all the things, here's where they are, here are their sizes, and then you say go. And then there's this animation loop, the draw loop in processing or P5, every moment in time. And what you do every moment in time is you say, oh, physics engine, where is the stuff? So you set up where all the things are, all of the things of like moving stuff around, checking if it's colliding, and then if it's colliding, velocity changes, all of that is done inside of this so-called black box, the physics engine, and your only job is to say, where is everything? Now I would like to draw it. So this is the paradigm that you'll find in physics engine after physics engine. And there's a bunch that I want to discuss and talk about. So let me make a list of different physics engines. We can talk about some of their features. So Box2D being one of the more famous, well-known physics engines that's behind a lot of well-known games like 2D mobile games like Angry Birds, fill in all the other ones after that. Box2D, there's a physics engine, and actually something called ToxicLibs, which is processing, what started specifically for processing, a Java library. It's actually a much broader library beyond physics, but one of its components is physics engine. There is something called a Bullet, which is a physics engine specifically for 3D. There is a physics engine I want to look at called Matter JS. Canon.js is another one I recently found, and the list goes on. So I'm sure I'm missing, your favorite physics engine or a really good one, or one that's really useful in this particular context or for this particular programming language. But this is a list of ones that I know something about or that I find useful in some context whatsoever. So one thing that you might consider, you over there, watching, did you run away? I would totally understand. One thing that you might consider is whether you can do this in 2D or 3D. So Box2D is, you might have noted by the name, is 2D only. 2D. ToxicLibs has both 2D and 3D physics. Bullet is a 3D physics engine. Matter.js is 2D, and Canon.js is 3D. So I don't know why they all get an exclamation point. They're very excited about their number of dimensions. I have a 2D physics engine. Another thing you might think about with physics engines is what features do they have? So what language is 2D or 3D, but really keeping these features. Actually, I realized that this list is kind of useless. I'll leave it there because I want to just take a moment to talk about, I missed the kind of key piece here, which is if I need to tell the world what kinds of things are in it, well, how do I do that? So what are the kinds of elements that go into the world? So almost all of these physics engines use the same paradigm, which is, and I'm going to use, each physics engine might use a slightly different term for the same thing, but for all these physics engines, there's generally something called a world. So the world is the entire world of what your sort of space, the physical space, whether it's 2D or 3D, that the entities that you're going to place in that world live in. And it could have, it could have kind of global properties, like it could have global gravity. It could have boundaries, where things can't go outside of. So typically, most of these physics engines have a world. Other thing these physics engines have typically is something called a body. A body being an entity that goes into that world. And it might be a circular body, a rectangular body, an arbitrary polygon type of body. And I'm kind of conflating something, though, which is Box2D in particular has two concepts, which is a body and then a shape. So the body meaning the sort of singular empty point that's floating, that's moving around through space, and a shape being actual physical geometry that's attached to it. So we can think sort of, but some of the physics engines that are a little less sophisticated are just sort of the same thing. Body and shape are the same thing. So body and shape. The other thing that most of these physics engines have is something I'm trying to think of which term to use. In Box2D, it's referred to as a joint. In Matter JS, it's a constraint. In ToxicLibs, it's a spring. And so I'm going to call it just a connection. I'm going to call it a spring. No, let's call it a connection. And so what I mean by that is, what if you had, as your physics engine, there is a body, and it's connected to another body that's swinging like a pendulum? How can you have a constraint or a spring or a joint that attaches two bodies? And it's kind of amazing what you can build just from that. Generically, if I have a way of placing any kind of shapes in the world, connecting them in some way that I want, and then saying go, experience gravity, bounce into each other, interact with the valves, experience a force, there's a lot of stuff, there's a lot of worlds you can create that are quite engaging, exciting, and to play with. So these are kind of the features, but there's a kind of key thing. I really should have started this whole video. If you're still watching, good for you. Because here's the real thing. When do you want to use a physics engine, and when do you not want to use a physics engine? And it's sort of like a strange question, because no matter what, you're using a physics engine. The question I'm really asking is, when do you want to just use your own custom-baked x=x+1 or position.add velocity, or your own kind of cooked-up mechanic for how things move around the space, versus just use somebody else's mechanic that you get to set up and then reap the benefits of as you draw things? And there's no answer to this question. And most of the time, you're in a sort of in-between space. But there are a couple scenarios that I think are key scenarios when using a physics engine is incredibly valuable. Key scenario number one: collisions. It's like real estate, location, physics engines, collisions. So if I'm ever working on a project and I'm moving stuff and using steer behaviors and I have gravity and I've got all this stuff cooked up in my code, what I really need is for these shapes as they move around to bounce off of each other. This is generally where I want to move towards using a physics engine, because rather than spend hours and hours in Stack Overflow and reading through lots of Wikipedia pages to work out all sorts of geometry, math, and collision detection and resolution, these are solved problems that are built into a lot of these physics engines. So that's kind of arbitrary thing number one we're on this whiteboard, which is to use collisions. Not to use a physics engine if what you use collisions. Here's another place. So what reminding me of this is this idea of physics engines having a world that's full of bodies and connections. And so one thing that physics engines are very good at is if you want to build some type of simulation that's based on a connected system. So some examples of this are cloth simulation, and a cloth simulation, how's that a connected system? Well, actually, I have a coding challenge that I'll link to here that builds a cloth simulation using the ToxicLibs physics engine. But you can think, well, what is a cloth? What if you had a lot of dots? You're going to have to watch this video for a little bit while I draw a whole bunch of dots. And then what if you connected all of those dots with some sort of springy, elastic connection, joined spring, and then you pulled on one? And I'll show you a version of this, and then I'll show you some examples. So this is when you textured it with color or whatever, that sort of thing. So cloth, hair, these types of connected bases. What if you wanted to make, a cute, cuddly character? Like this, I don't know, with some ears, and it's sort of like it's soft and it bounces and it jiggles and it wiggles around. Well, you could build this by creating a set of particles, perhaps, that are connected with springs and maybe some interior connections to keep it from collapsing on itself, and that could be the skeleton physics behind this particular character. And there are lots of examples. So the other thing that's sort of key about using physics engines is you don't have the way you set up the world and tell the physics engine what's in it could simply be a skeleton for what you lay on top of it. You might say, hey, there's a lot of circles in this world, but what you're going to draw are images of birds that are kind of circular. And there's a lot of rectangles in this world, what you're going to draw are like little cardboard box textures, wood box textures, that type of thing. So collisions is a key thing, and also connected systems. So these kind of soft body simulations, cloth simulations, chain, pendulum. There's a lot of scenarios where this idea, which a physics engine is going to kind of do a lot of this stuff for you, is a kind of known way of implementing something. Okay, so what I want to do here is, if thinking about collisions and connected systems, is I want to look at these and kind of think about what kind of features these engines have. So Box2D is like kind of amazing for collisions. So if you want to work with collisions in two dimensions of any arbitrary geometry, Box2D does this incredibly well. If you want to work with connected systems, springy, soft body simulations, cloth-based simulations, that type of thing, ToxicLibs does this really well. Now, you can do those kind of simulations in Box2D. The ToxicLibs is really just highly optimized towards this world of particles and springs, and ToxicLibs has no collisions. So ToxicLibs is just a particle spring-based physics engine with no geometry whatsoever. So in this sense, if you want to work with, so these are sort of features here. Bullet for 3D, actually really barely any springs whatsoever. Just give you one example that uses the processing library for Bullet, but for 3D collisions, you can use Bullet for that. And then Matter.js really, I would say, collisions and connected systems. Looking at it, there's a lot of features for both of those things. So you kind of, I guess there's a puzzle here, which is I'm working on a project that's, I want it to be in the browser, and I want it to just be a cloth simulation. Maybe ToxicLibs is all you need. Well, I'm working on a processing sketch, and I really need to have, I'm making a 2D game where all the stuff is like bouncing off of it, and all these like strange polygons. Well, maybe I'll use Box2D. But if I'm in the browser and I kind of just want a very generic physics engine that has collisions and constraints, and I'm going to use Matter.js. So hopefully, if you actually watch any of these videos and see some of the examples, you'll see where some of the physics engines really shine and where others maybe aren't as useful. One thing I'll say in terms of degree of difficulty, there's a level of complexity that the engine has, in terms, which if it has a high level of complexity, that's really great in terms of possibilities, but also makes the overhead of working with it so kind of extreme that it's sometimes not worth it. If all you want is like a bouncing ball, you don't really necessarily want to go through all of the rigor of importing all the Box2D libraries and learning how all the pieces work and you've got to set up all this extra code. But in terms of ease of working with, I would say Box2D is probably one of the hardest. ToxicLibs in many ways is one of the easiest, but it's a library from many years ago. Finding the documentation examples is a bit difficult to do, whereas Box2D has such a large user base. There's a lot of documentation and examples for it, albeit depending on what environment you're working with, there's not necessarily as much for working with in the browser. But Matter.js, one of the reasons I wanted to explore is it has a really nice website with thorough documentation and a lot of good examples. If I come over here, you can see, so this is an example of Box2D running in processing. And one of the nice things about Box2D it has a concept of a motor. So you can see there's actually the motor is on right now. If I click the mouse, you can see this is a revolute joint. It's actually a way of attaching two things based on like a singular point that one object can revolve around. And so you can see almost like a wheel. You can see without the motor, this kind of seesaw just responds to what's landing on it. But if I turn the motor on, it's going to turn and actually activate and start to hit these circles that are falling from the sky, so to speak. If I go to another use for, this is an example of Box2D, which has something called a chain shape, which I'm using to create this surface. And you can see here that I'm also using revolute joints. I can't remember if I made this example or not, but revolute joints to have the wheels of this car turn and move along this surface. So that's, you can see some possibilities here with Box2D. This is an example of using, these are called distance joints, which are like springs in Box2D, where all these circles are connected, creating this like springy like bridge. And if I click here, I can add rectangles to the system, and you can see they're kind of landing and getting caught on this particular bridge. So these are the kinds of things that you can think about making in a system like Box2D. Now, what else do I have to show you? So in terms of thinking about ToxicLibs and connected systems, this is actually a ToxicLibs simulation where it looks like, oh, I've got this like stringy rope-based thing, and I can kind of click on this and grab it and move it. But really what this is, if I were to go into the code just for a brief second and just change this to ellipse p.x, p.y, 8, 8, I'm going to draw little circles there. This is actually what's going on. So if I zoom in here, you can see that what this actually is, I'm not drawing the lines between them, these are just a lot of particles each connected by a spring. So when you pull on one, it pulls on the other, but depending on how I render it, I can render it all as a continuous line, which gives it kind of like a string-like quality to it. A string or rope-like quality to it. I can put this back, and I can display a larger circle at the bottom, and now you can sort of see more what it looks like here with this kind of view. So this is ToxicLibs, and I could open up another toxic libs example just to show you this idea of like the cloth simulation. So you can see this is a lot of particles all connected by springs, but in a grid with some gravity pulling down, and the two, they're just locked and attached to the top. And you can see it has a kind of cloth-like quality to it. And then Matter.js. So here's the website for Matter.js, and you can see what's really nice is just right on the homepage, it's showing you a lot of demos of the kinds of things you can do with Matter.js. This is my favorite, these little like card things. Oh, actually, that's my favorite. I love this one. I gotta build some of these as like a challenge or something. Okay, so that's a bit of an overview about Physics Engine. I'm doing this as a live stream right now. You might be watching this as an archive video. And so what I'm going to do is now take some questions from the chat to see what I missed and answer them. Okay, I've got a set of questions that came from the chat, but I'm going to try to answer some of them, and some of them might not be answerable, or I may not know the answer, but I'm going to discuss them with you to the best of my ability, and you're going to write the comments and help people come back and watch this video later to see other thoughts and perspectives and answers here. Okay, so first question here is from Nick, and I'm combining and rewording some of these questions. So Nick asks, how flexible are the engines, and how easily can you integrate them with code? And related to that, Jonathan asks, are there abstract uses of using these physics engines without even computer graphics and drawing simulation? If we come back over here, and I think in some ways there's a different answer for a lot of these questions. One thing that makes Box2D difficult to work with is Box2D is actually, in many ways, it's sort of a silly word to use, but a very pure physics engine. It knows nothing about computer graphics and pixels, and its units of measurements are actually meters, seconds, real-world measurements. Now, there's some nuance to this because it's sort of finely tuned for small units of measurements. But that aside, when you actually do this process of saying where all the things are, you have to give Box2D a set of locations with physical measurements as if it's in a real physical space. And Box2D will tell you where the stuff is at a moment in time, and you have to convert that back to a pixel space. So in that sense, it's incredibly flexible because it's abstracted from computer graphics at all. You could actually use it in the program and never draw anything, and kind of use it to simulate some aspects of things. It makes it kind of difficult to work with, but because you have to do all this conversion and thinking, and it makes it more complex than, say, Matter.js or toxic libs, where you can just give the engine pixel-based coordinates and it gives you back pixel-based coordinates. But it does give it a sort of level of sophistication and perhaps even accuracy. You could maybe say, I'm not expert enough in the lower level mechanics of all these engines to really say which one's more accurate than the other, but that certainly is an aspect of this for sure. Okay, let me come back and see what the next question is. FlipKidMC asks, can you use multiple engines at once? You absolutely could. I think you're probably asking for trouble in some ways, and I'm sure there are some very unique, interesting situations where that makes sense, but there's enough time and overhead in sort of learning, well, it's certainly worth learning multiple physics engines, but there's enough specificity to what are the objects that are available, what are the names of all the functions, and there's, each physics engine probably has its own vector object, and you can't give Box2D a vector from toxic libs, you can't give toxic libs a vector from Box2D, so you're gonna have to be converting. So I'm not so sure that you would really want to do that, but again, anything is possible because you are the designer of the system and you are the drawer of you're the person rendering the world. So you could give the information to multiple physics engines and try to like get stuff out and send it back, input it back in the other one to do some kind of crazy convoluted thing, but I'm not so sure. One thing I should mention is that you don't actually have to do this necessarily. Matter.js, and for example, I know very specifically has a kind of automatic debug view. So you can just say to Matter, here's a canvas, draw where everything is on the canvas, behind the scenes in its code has the ability to do that. But my point of view in showing you these things is really to focus on how you draw the stuff yourself, because that's where you can really layer in your own design sensibility. And that's kind of one of the questions here. I'm going out of order here, but Albert asked, like, can you use shaders and how can you really put your own design? Really, that's a really key aspect of being creative and working with physics engines and making something that's not just looking like a demo. So all of my examples are demos because I'm taking the physics engine and kind of drawing the literal pieces of it on the screen in kind of literal way. I'm overusing the word literal. But I'm just saying, what's in the physics engine? Let me draw exactly what's in the physics engine as sort of simple geometric shapes. Whereas there's no reason why you couldn't make fuzzy textures and blend modes and do all of your creative drawing using the coordinate and geometry information that's coming out of the engine. Okay, what else do I got here on this question? So this performance considerations is absolutely a big one. So one of the nice things about using a physics engine is that, assuming it's something that's worked on by a lot of people over a long period of time, all the ones I'm talking about are open source engines that are most of them source code is on GitHub and have a wide variety of contributors. But probably people have been working for years on optimizing them. So in many ways, it's going to be more efficient and have higher performance than what you might throw together in a day. That said, these types of computations are expensive. To look at every object in a system and where how it's colliding with every other object, and it's going to have some kind of complex polygon geometry. So there certainly is a slowness here. But Box2D is very efficient, runs very fast, especially if you're in C++, but it's going to run a lot slower in the canvas and the browser, drawing slower. So yes, there are performance considerations. Could I sit here and talk about them? I'm asking myself questions now. The answer is no. I think merits kind of a lot of trial and error and digging into the source code and seeing how things work best. Okay. Nick does not deserve credit for the first question. So I don't know who asked that question. It was a great question. It was not by Nick. Thank you. Let's see. Do some simulate more accurately than others? That's another consideration here. There's usually often a trade-off, right? It's going to be slower if it's more accurate. It's going to be faster if it's less accurate. Apparently that question is from Gabriel, perhaps. Another question here is from Philippe. How to use I reworded this question, but how to use forces with physics engine? Can you control velocity? This is a big question, which I will cover and look at in a lot of my examples. But the question really is, I kind of set you up in this way, like, hey, let's put stuff in the world. It's in the world. Now let's go over here. Let's read where the stuff is and let's draw it to the screen. But what if the thing that's in the world, I want to control how it's moving, or I want to add a force into the world that's going to affect the way that the world's behaving? So most of the physics engines are going to have a mechanic for this. For example, the body object, you create this body object, you put it in the world, you can keep a reference to that body object, and later you might be able to call a function called like add force or apply force to cause the body to experience maybe a sudden gust of wind, for example. There's a question though, like, well, what if you want to affect these not with a force, but by actually say, hey, I want this object's velocity to be this? And yes, physics engines will let you do that because number one is you can just kind of dig into the source code. Body's going to have a variable in it, so we're going to affect the velocity. You can set it, but you have to watch out. The big problem here. It's very easy to violate the laws of physics with physics engines. It's kind of hard to do that, although I would love, that's a good real world challenge. Let's violate the laws of physics. I'm sure that would be an exciting YouTube video, lots of views. But we can easily violate the laws of physics. For example, what if I just take an object that's in the world and I say, hey, its position is over here, now set its position to over here. I can actually do that, and it's going to appear over there. But what I've essentially just done is I've teleported it, which violates the laws of physics, at least in terms of physics engine. And so in that case, you might start to see some strange behavior. But if I wanted to move something around manually, through an interaction without teleporting it to cause some strange behavior, what I might be able to do is attach a connection. Maybe I attach a connection to the object and I connect it also to my mouse, and then I move the mouse around and I'm tugging it around. It's like I attached a string to something and moving it. So that's a way, that's one strategy for moving something around through a Perl noise algorithm or through user interaction by still staying within the sort of laws of physics of that world. It depends on how the physics engine works, but this is certainly a common problem. And another, it's not really a question I added to my list. Another very common thing about physics engine is, oh, it's doing all this collision stuff for me. That's great. Yay, I don't have to do the collision stuff. But what I really want is when they collide, I want to bing, play a note of music or something. So if you want to do that, you have to know when the things collide. And that's happening in here. How do you know when it collides? Well, you could say, okay, well, what I'm going to start to do is I'm going to look at all the things, I'm going to look at where they are in relation to each other, when they're within a certain distance, they must be collide. But then if you go down that road thinking, you've completely defeated the whole purpose of using a physics engine. You're trying to re-implement those collision algorithms yourself. So most physics engines will have this idea of a collision listener. So you can write a callback function or create some type of object that sits there and tells you information about, hey, there's been an event, these two things collided, here's object one, here's object two, here's their properties, what are you going to do about it? Say, oh, if it's a purple object with a red object, it plays C. If it's a green object with a pink object, it plays the note D. So you're going to want to look for something like a listener to be able to also not just extract where the things are that you want to draw, but to extract moments in time that are certain events, like collision events, that you want to handle in a certain way. Okay, so this is like a ridiculously long intro to physics engines tutorial video that I can't imagine anybody really wanted to watch. But if you're still here, thank you for watching. And I think the other videos in this particular playlist will have much more information and actual code about how to do these things and how they work. So I hope you watch them, I hope you enjoy them, and I'm sure, and I hope you leave me some comments or some feedback. Okay, thanks very much, and I'll see you soon. Hello again. Okay, this video, this section of videos is going to be all entirely about something called Box2D. Box2D. Let's write that over here. Box2D. Now, why are we talking about Box2D? Okay, so what have we been doing? We have been making all these examples. They have these mover objects. The objects have these vectors. They have these functions. What do? They move around the screen. They respond to forces. We've been building our own physics engine, bit by bit, slowly by slowly, looking at different examples and scenarios for simulating physics in motion on the screen. Of course, it's probably quite obvious to you that we are not the first people to have ever thought of this problem and ever done this. And in fact, physics simulation exists everywhere in computer graphics, and there are lots of examples of ways of writing code and libraries that you can use. So what we want to take a moment in this nature of code experience to say, okay, well, there's value to us building our own physics engine, to learning the ins and outs of it, to kind of being creative with what we're making, but maybe there is a time and place where we should just use somebody else's physics engine, somebody else's physics library to control the behavior and motion of everything on the screen. And so what I want to look at in this video is what is a physics library? What is Box2D? Where do I get Box2D? And what are the pros and cons of using something like Box2D instead of custom baking your own stuff? Okay, so this is going to be challenging. I made a list. We've got 8 videos to do. It would probably turn into more, honestly. It's a huge topic, and it's not going to be easy. But so this first video, which will just be a short, hopefully, I just want to kind of talk through the basic elements of Box2D, look at a couple websites where you can get stuff. I'll include links below wherever you're watching this, on Vimeo or wherever, of where you want to download the stuff, and then we'll get into the details in future videos. So if you kind of already, if you know what Box2D is and you're already up and running, you can stop now and just go to the next video. Okay, so Box2D. Let's think about why. What is the sort of central reason why you might want to use a library like Box2D? Okay, so I'm sure this scenario has come up for you before. You have all these circles moving around the screen, and you're programming them with vectors and forces, and they're all doing all this exciting stuff. But you want to figure out, you have got this circle and this other circle, and they're moving towards each other, and they're gonna get right next to each other. And you're gonna want to detect the fact that they're touching each other and they're bouncing off each other. You want to do something with their collision. If you have a program where the collisions of objects matter to you, if you have this idea for something you want to make, and you're walking down the street describing your idea to your friend, blah, 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 collisions, blah, 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 collisions, this and that, and then they collide, and blah, blah, blah. If you're using the word collision over and over again in your project description, this is a moment where probably you want to use Box2D. We could start to go through the math for this. And with circles, it's not so bad. We know, first of all, we know how to detect if two circles are intersecting or not, right? We can just look at the distance between those two circles. And if the distance between those two circles is greater than the sum of their radii, then they're not overlapping. If it's less than the sum of their radii, they are overlapping. And then we could start to figure out, okay, well, if they are overlapping, what do we do with them? Well, we know their velocity vectors. We could probably do some vector math and reflect their vectors and bounce them and rotate them, and we could figure out what direction they're going to go. And this would be a worthwhile exercise, and somebody someday should make a video about how to do this scenario. But this is the moment in our life where we are choosing not to go down this road, because this road leads to other more complicated and stressful problems, like what if they aren't circles? What if these are strangely shaped polygons? And what if those strangely shaped polygons are spinning? And how do we know if they're overlapping when they hit each other? How are they going to bounce off each other, and with friction? And what if they're kind of elastic or not very elastic? There's so many ways we could make this problem so unbelievably complicated. We could suddenly find ourselves dedicating the next several years of our life to figuring out just what to do about things colliding. The good news for us is somebody else already spent many years of their life dedicated to this problem, and they released the solution in an open source library called Box2D. So one of the central reasons why we want to use Box2D is to deal with stuff like collisions in 2 dimensions. Now, if we're going to get into 3D, we're not even going to get in this. About Box2D, we're sticking in 2 dimensions. This brings up an interesting point, though, which is that is there ever, you could be asking yourself, okay, that's great, but why would I never not use Box2D? I mean, that sounds awesome. I should just use that for everything. And you might choose to now use it for everything. But I do want to emphasize that this doesn't come without any pain as well, right? Using a library, you've got to learn how the library works. You've got to figure out how to import stuff, which functions, which classes. There's a lot of overhead. And as we're going to see, there's a lot of stuff we have to kind of learn how to use just to get a circle moving on the screen with Box2D is a lot more effort than without it. But once we get to the effort of having to deal with collisions, it becomes worth that effort to get Box2D up and running. So it's this kind of balancing act. And I'm very curious, actually. I don't pretend to have the answer to this. This is a question you will have to wrestle with. I have this idea for this project I want to make. Should I use this library? Should I use this other library? Should I use no library? And this is the question we hope to, as a community, wherever we may be, kind of solve together and talk about and discuss. And I would be interested in hearing from you as to what's worked with Box2D and what hasn't. So this kind of gets us over the hump of why we want to use Box2D. So there's 2 more questions we need to answer in this particular video. One is, where do I get it, and how can I even be up and running with it? And then kind of what is the overview? What's the bigger picture here? What are the central elements that I need to learn about? So let's first take a look at where it is that you get Box2D and what Box2D really is. The first thing I should mention, though, I'm going to include, this is so kind of analog of me, but here's a website that you could go to, box2d.org, and I'm going to include everything that I'm going to show you. I'm going to include as links below wherever you're watching this, probably on Vimeo. In the description, I'll include links. Okay, so what is Box2D? Actually, what I meant to write here, I'm just kind of rambling now, is C++. So So one thing we should be aware of is Box2D is a C++ engine. It's written in C++. And if you go back to box2d.org, that's where you can download it. You can find the documentation. There's a forum. There's information about the project. It's a C++ engine. It was created by someone named Aaron Kato, I believe. It's been around since 2007, something like that. It's probably in many ways most famous for its use in the game Angry Birds, and many mobile tablet games that you play are built with a physics engine, and Box2D is a very popular one, especially for 2D games. So one of the things that I think is most useful about this website that you might want to take a look at is perhaps rather dry reading, but if you're like me and you like to find something to read, quietly at night with the flashlight while you're about to go to bed, you might go here and look at the Box2D manual. So the Box2D manual is going to give you an overview of kind of what are all the pieces of Box2D. If you look at this, it's all written for the C++ user. Now here's the thing, Box2D is such an amazing and incredible library that does so much. We're not the first people to discover this. It's been ported to just about every language and environment you can think of. There's a JavaScript version, there's a Flash version, anything you can imagine, there's probably a version. Now, processing is built, as you may well know, is built on top of Java. So if we could just find a Java version of Box2D, we could probably use it in processing. And in fact, there is one. So if you go to jbox2d.org, you'll find a Java physics engine. This is a port of the Box2D library for Java. Now, we could be done here. We could just say, this is perfect, I found this, I'll download this, I'll figure out how to somehow get processing to recognize it and use it, and I'll write all this Java code. And that's essentially what we're going to do. But to make this a little bit easier, I have put together something called pbox2d, which I realize is sort of against the rules of library making, because the P is sort of reserved for official things. So maybe I should change the name of it. But I don't know why it just occurred to me now to edit this part out. But anyway, what this is it really isn't, it's misleading. It looks like it's a processing port of Box2D, but what it really is a little, it's really just a little, it's a set of examples in a library that allows you to sort of easily access jbox2d directly from within processing. So that's the details of this. This is what, as I look through my list of videos, there's like 8 of them. All of that's going to use this library called pbox2d. So you can see it's on GitHub. There's a link to download it. I'll include a link below. There's lots and lots of examples. I don't know if I had the time, and maybe I will. I could probably go through all of them. Hours of content here, but I'm going to try to whittle this down to the basics. Now, I should mention that this is not the only way to use Box2D in processing. In fact, there are other libraries. If you go to the processing libraries page, you'll see a few. BoxWrap2D, I think one is called. But one that I wanted to point out, which I think is particularly wonderful, is called Physica, which is, I don't know if I'm pronouncing that right. I say it with enthusiasm, though. Physica, which is by Richard Marxer. And this, I think, is terrific. I'm not choosing to use it because I think it's useful for us as an exercise here to really dive into the guts of Box2D. Physica is a little bit of a higher level layer. In many ways, it makes it a little bit easier to use, but perhaps not every. I actually don't know if this is accurate, but not everything in the entirety of Box2D has been implemented. So I want us to kind of get into the raw Box2D to really learn about how it works. So, but maybe I need to reconsider that because this is really a wonderful library, and I definitely recommend you taking a look at it. Okay, so this is the picture of where everything is. Now, let's just discuss for a moment, though, kind of looking at an overview of all of the elements in Box2D. You know what? Actually, that's going to be in the next video. I think this is good. Here's the thing. So this is what you should do. You should go and you should download this library, pbox2d. Use the link below. Download it, open it, get it running, go through all the examples, and just run them. Take a look at them, and sort of just see if it makes sense to you that this is something that you think you might want to use. That's going to add value to the stuff that you're making. And if that's the case, then continue and watch the next set of videos. If not, go and have a sandwich or a nice salad or something. Take relax and do something else. Okay, so hopefully that gives you kind of a basic overview of what Box2D is and when you want to think about using it. The next video we're going to get into kind of another overview, but with more details about the elements of Box2D and how they're used. And then finally we'll start digging into the code details as well and see how to actually write code that use Box2D. Okay, goodbye. All right, so now we know, hopefully we have Box2D, we've downloaded, we're up and running. We need to answer this question. How does it work anyway? Like, let's go, how does Box2D work? So let's first, before we get there, let's first think about how a regular non-Box2D sketch works in processing. Okay, so what does a processing sketch have? It has setup, and it has draw. And in setup, maybe you create all the objects in your world, right? You create a bunch of objects. Create a bunch of objects. And then what happens in draw? Every time the sketch cycles over and over and over again, we calculate the motion of every object, and then we draw every object. So we calculate, I'll say calculate the physics, location, add velocity, add acceleration, apply force. We do all this stuff with everything. And then what do? We draw everything. So this is kind of how we've been writing our sketches. What we're looking to do with Box2D is replace this line with ask Box2D to calculate the physics, right? We still need to create everything, and we still need to draw everything, but we don't need to update all their locations and do all that math. Box2D is going to do it. We can think of Box2D essentially as this magic box, right? There's this magic box, 2D, right? And what we do is we create a bunch of objects in setup, and we put them in the magic box. And then every time through draw, we say, hey, magic box, where is everything? Where is everything? It's a very strange diagram here saying, okay, what we're going to do is create everything, put everything in the box. We say, hey, there's a whole bunch of squares and a whole bunch of rectangles and a bunch of triangles, and they all start here. And then go. We back away slowly, and we just say, where is everything drawn on the screen? Where is everything drawn on the screen? And we don't know how stuff is moving. That's up to Box2D. It's taking care of that. So the good news about a scenario like this is we don't have to do all that physics math, our code, and figure it out and debug it. It's all done for us. The bad news about a scenario like this is we lose a lot of control here. We are just kind of just saying, draw everything, and I'm sure you're doing it correctly. Thank you very much. And so this is a good thing. Some projects, this is perfect for. Other projects, this is not so perfect for. And this is the question you're going to have to ask yourself when you're kind of figuring out what tool to use to create what you're creating. But so this is the overall structure, and we're gonna see how this works in an actual code example in the next video. I'm not timing this, shoot. But in this video, I have a couple more things that I want to talk about. One is what goes in this magic box. So this is kind of key. What goes in this magic box? So let's erase all this over here, and let's talk about what are the central elements of Box2D. What are the things we're going to have to learn about to use Box2D? So Box2D has a bunch of elements. Number 1, there's something called a world. Number 2, there's something called a body. Number 3, there's something called a shape. Number 4, there's something called a fixture. And number 5, there's something called a joint. So these are the central elements of Box2D. These are the kinds of objects that we're going to make. We're going to make bodies, we're going to make shapes, we're going to make fixtures, we're going to make joints, and we're going to put all those things in the magic box, and then we're just going to ask, where is everything? We would like to draw it with our own special colors and design and images, etc. So the key, so the world, first of all, we should kind of leave world up here. The world is this magic box. So that's the world. The first thing we're going to do in a Box2D example is create that world. The second thing we're going to do in a Box2D example is start to put bodies in that world. The body is the central element that moves around the screen. It is the thing that has the physics. Has the physics? Can something have the physics? Anyway, it's the sort of central element. The interesting thing about a body is it is nothing. It's nothing. It's emptiness. It's just like this empty point that's moving throughout the screen. A shape is what actually has geometry. And a shape is what gets attached to a body. So if we look at a window, The body is this point that's going to move around and it's going to have a velocity. A shape is going to be the actual thing, you know, our little angry bird here. I don't know what I'm drawing. I can't believe I'm doing this. That's edit, skip, something, fix, whatever. Okay, so the shape is the thing with geometry. That's the actual shape. Is it a rectangle? Is it a polygon? Is it a circle? That's the thing we're going to attach to our body. How are we going to attach it to our body? With a fixture. So you can start to imagine here that you can see how using Box2D, even though we have this magic thing, right? Oh, it's going to be so easy. We just set up things in the world, then we ask where is everything, we draw, it's going to be so easy. It's not so easy because we got to make bodies and we got to make shapes and we got to make fixtures and we got to do all this stuff. So this is when we get to the code example, which we're very slowly inching our way to. In the next video, there's a lot of details we're going to have to work out. And most of this we can copy paste and just sort of look up. You don't have to memorize it, so to speak, but it isn't so easy. So the body is the thing. That's the mover. This is the equivalent to the mover class that we've been making all along. The difference is now our movers didn't have geometry. Sure, we drew something on the screen, but there was no collisions. So we have to start worrying about geometry, which we have to define shapes that are attached to bodies with fixtures. Joints, by the way, we're going to start to look at later toward the end of this section of videos. A joint is something that connects two bodies. So when we think about the pendulums we made, or the springs, we might have a body and a body connected with a joint. That could be like a revolution joint. It could be a springy joint. There's a bunch of different kinds of joints we could look at in Box2D. Okay, so this is the overall picture. And I think that's pretty good for right now. What I would suggest to you, what I would do as your exercise here before the next video is make a basic processing sketch. Make an object that has a location and a size. Maybe it's a square, maybe it's a circle, and make an array list of those objects and just stick a whole bunch randomly on the screen or wherever you click the mouse, add objects. So make a sketch with no physics. It's just going to be a sketch, and I'll show you an example of this. Make a sketch that's like this, that I can just add objects to and they don't do anything. What we need to do in the next video is actually take a sketch like this and stick Box2D in it. Say like, okay, instead of just these objects that are drawn on the screen, we now want to have those objects move according to the physics of Box2D, and Box2D is just going to tell us where they are and what their rotation is, and we're going to draw according to what Box2D tells us. That's what we're going to get through in the next video. Okay, any questions? I'm sure you have many. Okay, so I'm going to click this, and I'll see you in the next video. Well, previously I said in this video we'll be getting to actually writing the code and making our first Box2D example. But this is the thing, you know, Box2D, it sounds so amazing, it's just going to solve all of our problems, but it might solve some of our problems. I have many problems, which it has not yet solved, but it's complicated. So here's the thing, I forgot something. And so before we can get to this, writing the actual code into our example and making Box2D, having Box2D calculate the physics for us, we need to talk about one more thing. What is that one more thing? We need to talk about Box2D's coordinate system. So, you know, we have this processing window. And it has 0, 0 in the top left. And it has a width, you know, 640. It has a height, maybe it's 360. It has all that stuff. It's all pixel coordinates. It's pixel coordinates on the screen. Here's one of the wonderful things about Box2D. Box2D is a physics engine in the purest sense of the word. It knows nothing. It cares nothing about our processing window. It's actually doing all of its calculations in meters, in seconds. It thinks about the real physical world. We are creating, we have to give Box2D numbers that correspond to things in the real physical world. Well, here's this, you know, object. It's 3 centimeters long, and it's a meter away from this other object. We have to really work in those terms, which is a little bit strange because everything we've been doing all along is like, you know, the middle of the screen is 360, 180, and hey, let's draw this and pixel coordinate that. So we've got to take a whole new way of thinking. And in fact, this little diagram we have, which is sort of describes the magic of how simple Box2D is, which is, you know, make a bunch of objects, set them up in the magic box, Box2D's world, and then every time through draw, just ask, where are they? I'm going to draw them. Where are they? Where am I going to draw them? So we need to add 2 steps here. Convert from pixels to world. So whenever we say world, that's going to refer to the Box2D world, which, you know, corresponds something to like our actual world, but in 2 dimensions. And then, so we create our objects, we think in pixels, we convert them to world coordinates, send them into Box2D. When it's time for us to draw them, Box2D is going to give them to us in world coordinates. So we have to convert from world to pixels. So what does it mean to do this? So one of the things that the key Box2D, this helper class that I've created, does for us is it has a bunch of functions for these conversions. They're not that complicated. It's just a matter of translating and scaling. This is our processing world. Box2D's world is just the Cartesian coordinate system you might have done in a high school geometry class. You've got 0, 0 at the center. and you've got the y-axis pointing up, and the x-axis pointing to the right. This is the same as our processing world, except in our processing world, 0, 0 is in the top left, x points to the right, the y-axis positive points down. So it's the same but flipped and much smaller. So Box2D is not tuned for large distances. It kind of works well for, like, the Angry Birds thing. We have this little tiny bird flying across and bouncing into a bunch of boxes. So generally we're using small numbers. So something that might be 100 pixels wide should not be 100 meters wide. That would be somewhat insane. So, but all of that is going to happen for you behind the scenes. There's absolute ways of digging into that and tuning it in a custom way, but we're not going to. We're going to sort of stay in a comfortable, soothing, relaxing place. We're going to let the P-Box2D helper class kind of manage that conversion for us. Now, there's another aspect to this. Oh my goodness, so many things. This is definitely going to be an entire video, just kind of about this little topic here, which we need to prepare ourselves. Again, what is the syntax? How are we using that? That's going to happen in the next, this moment that I keep saying is going to happen eventually. But before we can even look at implementing this, there's another piece of this puzzle, right? We spent all this time learning about something called p-vector. I guess I'm just going to erase all this. We spent all this time learning about something called p-vector. Box2D, we now need to learn about something called vec2. So this is just a kind of hard truth of the world that we live in. This idea of a vector is a general concept in physics, simulation, motion, programming, computer graphics, all that stuff. And when we are in processing, so we're using p-vector. If you use, if you ever program something called open frameworks, you might be using OFX vector. When you're in Box2D, you're using something called vec2. When we use toxic libs a little later, we're going to see vector 2D, vec2D, vec3D. So there are lots and lots of implementations of vector classes everywhere that you can look. The good news is the concepts are all the same. Everything we learned about adding vectors, scaling vectors, normalizing, magnitude, all that stuff, it exists in p-vector, it exists in the Box2D vec2 class. The thing that's a little bit unfortunate is the syntax is always going to be a little nuanced, a little different, and no, maybe we like that syntax, maybe we like that syntax. I'm not really sure which one's better, but we just have to, we don't have to memorize them both. We have to feel a little bit comfortable with them both. So just to kind of cover this in a little bits here, whereas when we said in processing in p-vector v equals a new p-vector, right, with some coordinates in them, whenever we make vectors when we're using Box2D, we're going to make vec2 objects. So it looks the same exact way, an x and a y, but instead of being a p-vector object, it's a vec2 object. And there's a lot of other things, like we did location.add velocity, added velocity to location. If we go look at how the syntax works in vec2, you'll see that it's location.add local, sorry, I didn't write that very well, add local velocity, right? So, in toxic libs, we're going to see that it's add self. What's going on here? Velocity is being added to location. Velocity is being added to location. So it's just called add local to emphasize that location is changing here. Multiply is the same thing. Instead of processing, it's mult. In vec2, it's just mul. Normalize is the same. Normalize is the same in both places. Magnitude, however, in processing, we could get the magnitude of vector v.mag. In vec2, I believe it's v.length. So we just need to feel a little comfortable with all these differences. And I really, really desperately want to point you to a place right now where you could just see a list of these. If you look at the Nature of Code book, there's a little section, and that's the link that I'll include, that has kind of the functions and their corresponding names. You can also look in the JBox2D documentation. So if you download JBox2D from the JBox2D website, it'll have the Java docs, which will have all the functions for vec2. So this is just something we need to be comfortable with. So, okay, so we know there are two things. We're getting closer now. We know that we're going to make vec2 objects. We're going to have a vec2 object maybe called position. We're going to want to tell Box2D about it. And then later, we're going to want to ask for the new position back. So remember, we need to do a conversion. So how do we do those conversions? The P-Box2D helper class has a set of functions that will take a world coordinate and convert it to pixels, or a pixels coordinate and convert it to world. These functions are somewhat really, I just have to admit, they're really awkwardly named, and I'm just open competition. If anybody has a better naming convention for these functions that want to suggest one, I'm totally thrilled to rewrite this library to be a little simpler. But just to kind of go through what those are, for example, when we are converting, we set up, we were thinking, okay, I want my xy to be, I want my object to be right there on the screen. That's its pixels coordinate, but I need to tell Box2D about its world coordinates. The function's going to be called coord pixels to world. And then we pass in the xy. So this is going to be how we're going to convert from a pixel location, and out is going to come the world location that we're going to pass into Box2D. When it comes out, we're going to get that world location, because Box2D is only thinking in world, knows nothing about pixels. Then it's going to, we're going to get that world location, and we need to convert that to pixels. So to convert that to pixels, we're going to say coord world to pixels, and we're going to pass in an x and y. These functions, these conversion functions can take two arguments, the x and the y separately as floats, or they can take a vec2 object. So it can take a vec2 object and give you the converted one back. So we're going to see there's lots of functions like this. We're also going to need to do this for sizes. If we set up a box, with a given width and a given height, we're going to have to convert that pixel width. Like we know we want our box to be 100 pixels wide and 50 pixels high. But what is it in Box2D world units? We're going to have to say scalar pixels to world W. So you can start to see the convention here. We might convert a coordinate, we might convert a scalar, we might convert a vector. There's a list of functions, and we're going to see them in the examples. As we look at the examples, I'll point them out. Again, this is a big topic, lots of code, lots of things we need to work out. There's the book, there's what I'm talking about, there's the examples. Let me know what's missing, but hopefully we're going to figure this out together. Okay, so you can see all these functions, but there's one little detail that's kind of important. When we draw a rectangle in processing, we think of the rectangle as having a width and a height. The full height, the full width. Box2D thinks about the width and height of a rectangle as the distance from the center to the edge. Right? So that's the width and that's the height. So when we convert in the code examples, you're going to be seeing that we think of our pixel width. Then when we convert that, we need to divide it by 2. So these are just the little details we're going to see as we start to build this processing example that's actually going to have elements that we're going to create, put in the Box2D world, and get those locations back out. Okay, so this is a lot of jumbled stuff here. What I hopefully want you to take away from this is we need to understand about converting between pixel coordinates and Box2D world coordinates. We're going to be going back and forth a lot. We'll see this in the examples. And we need to realize that all of this math that we're going to be doing with Box2D vectors is going to use the vec2 class, which is very similar to p-vector but with different syntax. So if you're confused about this, rewatch this. Maybe that'll help. Take a look at the section that I'm linking to in the Nature of Code book. This is now we kind of gathered all the pieces, and we're going to actually look at the code implementation and make our first Box2D sketch in the next video. Okay. Hi. So here's our goal. We want to get to the point where we have written example, what corresponds to example 5.2 if you're following on the book. So if I run this example, we see this is hello world box2D. We've got boxes coming out of a point. They're falling, they're responding to physics, they're colliding, they're bouncing off of these platforms. All of the physics in this example are being controlled by box2D. If you look through the code, you'll see all we're doing is asking where's the location, what are the angles, and drawing everything on the screen. So how are we going to get there? So here is our exercise. We're going to back up, and I'm going to show you, look at example 5.1. What is example 5.1? It is a very simple processing sketch. We have an empty array list of box objects. Every frame we add a new box object. And so here we can see I'm adding these box objects. Our exercise here is to give these box objects physics. So let's look at the code for these box objects. These box objects have, oh, I already typed this in there. Erase that. These box objects have an x and a y and a width and a height. They're static, and a display method. That's it. If you kind of rewind yourself all the way back to the beginning of this video series, this is what we were doing. We said, aha, we want to add location, velocity, acceleration, an apply force function, an update method where velocity goes to location, acceleration goes to velocity. We started to write all the code for the physics. Now we're going to take a different approach. Instead of writing all the code for the physics inside of this class, we're going to store a reference to a physics object that comes from box2D. What is that physics object? I had typed it in here before. It's a body. So instead of location, velocity, acceleration, we get a body. The body has all that in it. The body updates itself. It figures out if it's colliding with things. We don't have to implement any of that. We just want a reference to that body. That body is going to have to be given an initial position, an xy, and a size, but then it's going to be updated through box2D. So this is kind of a new way of thinking. It's like an object within an object. Like our object is a box, but our box object, really what it is, it's a reference to a box2D body. So the different approaches here, and when we get to toxic libs, we're actually going to see a different approach to this kind of thing. But this is the approach we're taking right now. So the question becomes, first and foremost, how do we make this body object? And unfortunately, the answer to this question is somewhat of a nightmare. And there's a lot of steps involved, and the code is a lot of syntax, a lot of methods, and things to remember. And I don't know that there's any way that you would be able to complete this exercise. You could try to look up the reference to the documentation. So what I'm going to do is talk through the steps to initializing this box2D body. It's 4 or 5 steps. We're going to talk through those without code, and I'm going to look at the code implementation of that and point out where where the reference is to kind of look up where all these functions are and what are all the parameters. But there's no way to kind of, I think, easily go through all of it. I tried that in the previous video, and I didn't think it was very good. So anyway, here we are. So this is our job right now. We need to initialize this body. So I'm going to talk you through the steps of how to initialize a box2D body. Okay, so step 1, create a body definition. And I'm going to call it body def. So this is a body definition, but the actual object we're going to create from box2D, from JBox2D, is called body def. Now this is kind of a strange thing. Didn't we say we wanted to create a body? This is just the way box2D and lots of things work. In order to create a body, we need to create a body definition, and from that body definition, we'll make a body object. So it's just kind of the organizational principle that we're working under. In theory, you can make multiple bodies from one body definition, but we're not worrying about that right now. Okay, so create a body definition. Now the body definition is where you set 2 really key parameters to the body. One is simply, and there's a bunch of things, its initial position. So where is it going to start in the world? It needs an initial position. The other thing we're going to give it is a type. Type is very important. We're going to see 3 options. I guess I'll write these down for you. Dynamic, static, I spelled that wrong, and kinematic. What are these 3 types? Well, to start, everything is basically going to be dynamic. A dynamic body is one that moves in response to physics. That's what we want. We want a body that moves in response to physics. If you remember, though, in that example 5.2, there are those platforms that the boxes are landing on. Those are static bodies. A static body is kind of an artificial thing. It's a fixed body that can never be moved, which is useful in lots of worlds you might want to make. Kinematic is kind of a funny thing, and we'll get to it, hopefully. I don't actually have it on my list, but we should get to it in a later video. There are often times where you want a user-controlled object in the physics world, right? We know we want static objects, ones that just move and respond to physics, but you might have one that's controlled by the mouse or controlled by your hand in a computer vision tracking system. So that is a kinematic body. So when we create that body definition, we need to set the position and the type, and we'll see that when we look at the code implementation. Number 2, we now need to create the body. So this is simple. This is just going to be one line of code. Once we've defined the body and all of its parameters, and there's other parameters as well you can define, like you can give it initial velocity and certain things, but we're just looking at these 2 right now. Then we can create that body object. So what's the funny thing about a box2D body? So if this is our box2D world, we can think of the box2D body as like boop, a little tiny dot. It's emptiness. It's nothing. It's just this sort of point, singular point that moves throughout the space. The magic of box2D, the wonderfulness about box2D, is that that bodies have geometry. But bodies don't have geometry, but we can attach geometry to a body. We can give it a shape. So the next thing we need to do is create a shape. The shape is what is going to define what that body looks like, how it responds to collisions, what is the form that it's actually taking. The body is just a sort of empty soul, and the shape is the form that is attached to that soul, if that makes any sense. So when we create the shape, we can create a number of different kinds of shapes. Just some examples are polygon shape. That's what we're going to start with. A polygon shape can be any arbitrary polygon with any arbitrary set of vertices, or it can be something like a box with a width and a height. Another kind of shape that we can create is a circle shape. So if we have circular objects, you can imagine what that is. We're going to create a circle shape. There are other things too. One that just jumps to my mind right now is chain shape, and we'll look at some examples of a chain shape. A chain shape is something you might use for a surface, like a terrain in a 2-dimensional world. So there are different kinds of shapes. And once we create that and define that shape, what needs to happen is that shape needs to be attached to the body. So the body experiences the physics, location, velocity, acceleration. It gets forces applied to it. The shape is the geometry attached to that body. The way we attach a shape to a body, I know this is super exciting, right? Is a fixture. So we need to create a fixture. A fixture you can think of as the glue that binds the shape to the body. The interesting thing about the fixture is the place where we get to set some other physics parameters, notably density, friction, and restitution. Density, friction, and restitution. So density, you can imagine, if an object is more dense, it's going to have a higher mass based on how big it is. So density can affect the behavior of something by making it have a kind of weightier feel to it in the physics world. Friction is just how much friction does that body experience when it comes into contact with another, does that shape experience when it comes into contact with another shape. And restitution you can think of as elasticity or bounciness. So if you're dropping, if I had a nice little basketball or something, and I were to drop it, how much would it bounce off the floor versus how much would it sort of just land with a thud and not bounce back up. So, and I'm dropping things out. Okay, so these are all the parameters we get to define when we create this fixture, and the very last step, which if I'm still on the board here, is kind of put it all together. Now I'll just write that out here. Put it all together. Putting it all together means use the fixture to attach the shape to the body. So if you recall, right, we started with this question of, I want my box object to, instead of me having to add location, velocity, acceleration, work out all the physics, I'm going to add a body to it. I'm just going to put a body object to it, and I need to, probably the constructor initialize that body. So you would think that would just be body equals new body xy. Boom, I'm done. And it's just not that simple. Box2D requires a lot of steps to set up all the initial parameters about the body. Where is it? What kind is it? What's its shape? How's its shape attached? What are the physics parameters? And these are those steps. So these are those steps. So in the next video, what I want to do is actually look at how do we take each one of these steps and apply it in code. So there isn't really a good exercise to go from this one to the next one, but one of the things I would say that you might take the time to do is go back and review now. Go look at that Box2D manual. So go back and look at the link to the Box2D manual, read the little section about the body, read the section about shapes, read the section about fixtures, and see if any of this kind of like is starting to gel into your head. And in the next video, we're going to look at each one of these steps in code and see the example really happen. Okay. So this is the video where we're actually going to start looking at the code implementation and how we're going to get these boxes to suddenly start falling and bouncing off each other. So if you remember, we have this box class, and what we said is, aha, instead of adding all the physics into that box class ourselves, we're going to add a Box2D body into that box class. And how do we do that? We've got this long list of steps that we went through. So we need to look at the code implementation for each one of these steps. But before we can even do that, we have kind of a larger question, right? Just putting bodies into a box object isn't just the only piece of this puzzle. We need to do, I'm going to divide this into three things, or three things we need to add to that processing sketch to have full-on Box2D physics happening. So number one is we need to deal with the Box2D world. So where we're going to do this is in the main tab. And more specifically, we're going to add the Box2D world into processing's setup. So this is a key thing here, right? The body is the entity in the world that moves around, but in order for the body to exist, it's got to be in a world. So the world is something we're going to set up when we begin our processing sketch. That's item number one. So item number two is what we spent all this time going through. So we need to create bodies, create a body, and where we're going to do that is in our own objects constructor. So our object is called a box in our objects constructor, the box objects constructor. So every time we make our own object in that object constructor, it says, oh, you're making an object, I got to make a Box2D one to go along with it. So every one of our objects will have a Box2D object, a Box2D body that will go along with it. Once we've done that, we're pretty far along, but what we actually need to do, remember, we're the designers, we're going to draw everything, set the colors, set the shapes, load images, design our world. What we need to do is ask Box2D where, we need to rewrite our display method. So we need to ask Box2D where. Where is the body? And where we're going to do that is in the box's display function. So up here, we have this idea of, in the main program, we're creating a Box2D world. In our objects, we're creating body objects. And then when it comes time to draw that object, we're going to ask that body object, where are you, so I can draw you in the right place. Okay? So these are the three things we need to add to that processing sketch. So what I've done is a lot of code. We're going to have to sort of deal with the fact that how could you ever possibly remember all the code that you need for each one of these steps? And there's this body type, dot this, add this, blah, blah, blah. So we're going to have to sort of piece this together. It's going to be a little bit challenging. But what I have over here is I have a version of this exercise, sort of semi-solved. So it has maybe 60 to 75% of the code already written. So we can look through some of that. And some of that I'm going to add as we go here manually and try to see if I can remember it. So, so one thing that I'll first note is related to item number one, which is set up the world in our main program, is we need to import all the library. So there's lots of stuff we're importing. We're importing a whole lot of classes from JBox2D. We're importing some stuff from PBox2D, a little helper class to provide us with some functionality. So there's a lot of stuff that's being imported here. We're later, hopefully at some point in this video, I'll kind of go and show you where you can kind of look up all the documentation for this stuff. But one of the things we get from the PBox2D library is we can make a PBox2D object. And I'm going to call it Box2D. And this, we make a new PBox2D object. And this is where we create our world. So the PBox2D object is kind of the main object. You can make it sort of a global variable for your entire sketch, and it is what is holding onto the Box2D world. So all of the information that's about the world, does it have, what's the gravity force in the world, or other parameters of the world that you can look at, setting, but we're just creating a world with default settings. So we need in processing setup to create the PBox2D object and call Box2D.createWorld. The other thing that I should look at, point out that we need to do in draw, is we need to say Box2D.step. So remember Box2D, if you remember, I think we covered this, it's a library that thinks in terms of real-world units, seconds, and time. So one thing we have to do is every time through draw, we have a new frame of animation we're going to display on the screen. We have to tell Box2D, step to the next moment in time. So Box2D, step to the next moment in time, we're going to draw everything. Step to the next moment in time, we're going to draw everything. Step to the next moment in time, we're going to draw everything. What's interesting about this is you can start and stop the physics by deciding when you're going to call step. But here, we're just operating under this methodology of every time through draw is one step through Box2D time. So this we're done. This is, I believe, until I realized I forgot something. This is everything we need to do to add the Box2D world into the main tab. So the next stuff that we need to look at is creating the body, which we want to do in the constructor of the box object. So the moment we create a box object, we want to create a body to go along with it, with all these steps: body definition, position, type, body, shape, fixture, and put it all together by fixture takes the shape and attaches it to the body. So most of this I've typed in already, and I'm going to kind of scan through it. I think it's going to be up to you to kind of download the examples, look through them, see what the questions are. But I think it's not useful for me to sit here and type out every single one of these lines of code. I'm telling myself this because I'm not entirely sure. But I've left a few mistakes out. So we'll see. Watch what I'm about to show you. See if you can see. There's a fundamental sort of horrific flaw in this code that we'll fix. But first we can see where step one, define the body. So we make a body definition object. The type is dynamic. You can see here. This is where we might set a static or a kinematic one. But here we're making a dynamic body. And then the other thing we need to set about a body is its initial position. Where is its initial position? Its initial position is xy. Do you notice anything wrong here? Think about it. Its initial position is xy. What is xy? xy are the arguments I passed in here. Mouse x, mouse y. What are those coordinates in? Those coordinates are in pixels. The mouse location in pixels. Remember, the Box2D coordinate system is completely different than our pixel coordinate system. So this is a moment where we have to stop, pause, and convert the pixel coordinates to world coordinates, Box2D world coordinates. So I'm just going to show you that instead of passing in xy directly, you can use one of the helper functions we covered, coordinate pixel to world xy. So this is where before you set that position, think to yourself, am I setting a world position and am I thinking in pixels? I've got to convert it. Okay, so that's really important. So that is step one, create the body definition. Step two is create the body. Remember we said this was going to be really simple. Well, it's one line of code. Create the body from that body definition and store it in the body reference. Easy peasy. I can't believe I just said easy peasy. Okay, the next thing we do is create a shape, and we're going to use polygon shape as a box. And we can see here, we are creating a polygon shape, and we're making it a box with a width and a height. Again, the same problem is here. What is that width and what is that height? We're thinking in pixels. We've set them up to be 16, a width of 16, and a height of 16. Those values are in pixels. We need those values to be in Box2D world units. So we're not converting a coordinate, we're scaling a scalar value, a single number. So what we need to do is say this. Float, I'm going to just make a new variable, Box2D width equals Box2D.scalar pixels to world W. And I'm going to make one for height, scalar pixels to world height. And you can see, and now we need to set the actual polygons width and height with the converted values. Right? We need to scale the width, scale the height. Okay, we've forgotten one other thing though. So this is pretty close. We've almost got it right. We got the pixels, we converted it to world, and we set it, but we missed one little tiny thing, which I will show you, which is that
think I won't spend a lot more time, but probably at least one more hour. Then no slop. I'm gonna put some electronic music. So I think I got it. It's passing that as the argument, so this is going to be the class that the function extends, and is calling right after declaring the function. I forgot the name. I think it's IIFV, something like that. When you declare a function and then you call it right away. I think that's the pattern here. So it's passing. This is going to be the React doc component. It makes the function extend the React. I think I understand. So this function here receives the other function and then creates a class based on these properties here. So I have to understand how this function works very well and how these other functions here work. Like intuitively, I think it's easy to understand because the way that they put the names. Not sure if that's the right way to say it in English, but so it's like creating a function, then extending the React component class, and then this function here creates the class based on the other function, which is this one, and it's gonna add all of the. I think like the key is gonna be the name of the function, and the value is gonna be the function. So it's pretty much adding this life cycles to the React components. I think I need to understand more of the React components. Because I don't have a lot of experience. Like so far, all of the stuff that I did was only with functional components. I almost never used class components. And I, even after watching a bunch of videos, like those videos explaining the fundamental, like the way that React works under the hood, even after that, I like still don't get it. It's not intuitive to me. Like I don't remember really well how the class becomes the virtual DOM there. Okay. At the end of the day, just an object with values, obviously because it's a tree, but I don't remember really well how it works. And then it makes the prop types equal to. And this part is just adding the props there that you pass. So these are going to be the props you pass to the component. Which are these values here. Well, let me think about it. Like intuitively I understand, based on the functions here. It's not that hard, I think, to understand. Because the way that they wrote everything makes it easier to understand. I need to understand what is this Pixi fiber, but I think it has to do with the thing about React that I also forgot, which is the fiber thing. I think I'm gonna watch that playlist off stream. This one. I've watched this 2 times already, but I'm gonna watch. It's because of spaced repetition. I'm gonna watch this a bunch of times until I internalize everything, so I know intuitively what's going on. Well, let me think about it. So What I wanna clarify is the children. I have to like study this class here. Then what else? Then I think it's more about studying the Pixi classes now. But maybe I'll clarify this more. Yeah, I need to understand how the interaction system works on the Pixi class, the application. So I guess the question is, how does this one, I think it's on this function that it creates the applications. So on the onMount component did mount. Yeah, here's where it creates the application. I need to understand more this, how this one works, how this one works. And then this is gonna be the app. So I need to understand the Pixi fiber more. Container. So I guess like the thing is I don't remember really well, but fiber I think is a part of the tree, of the React tree. So this is mounting the component in this fiber thing from React. Is mounting the stage. Reconciler changes. Yeah, so I just need to understand more this class and then how this class is related to the interactions. But probably the way to do it is just to use the use app, and then I use on the world here, just get the app here, and then from this I set up the event listener. It's gonna be app.renderer.interaction or whatever the name of the class is. And then I think it's on, then wheel, and then I put the function. And here I change the scale of the view. So I need to know the methods for the view, and I also need to understand how these things change the actual WebGL parts, because there is the module, the projection, the model, and the view. Those are the three components, I think, that make up the visualization. And then there are the elements. Each element has its own coordinates, and everything is connected through the hierarchy of the tree. So I have to understand how the update cycle works. And I think that the relationship between Matter JS and the view is that the Matter JS just controls the constraints of it creates the world, so it controls the physics. So it's like the React-pixi is controlling your view, which is the camera, but it has no say on the laws of physics, and the Matter JS just controls the physics. So, but I think like there needs to be, yeah, maybe when you scale the view, it doesn't matter for Matter JS, because Matter JS is just related to the physics. So But it is related because of the position of the coordinates of the bodies. So I still don't know really well how that works. Maybe it's better, yeah, I should change here actually, instead of changing on this one. To put the update of the view. So the question is, how does changing the scale is going to change the positions of the elements inside of the thing, and how is that going to change the Matter JS calculations for drawing the shapes? I think that's the question. How are the shapes being updated? Because I'm adding the shapes to the world through this. So it's like I'm adding the bodies to the world, and then the bodies have the constraints of the physics. The world has the constraints of the physics, and then I'm adding the body to there. But then how do I update? Here I'm using, maybe I should use the use stick here as well to resize the. Yeah, that's the tricky thing, because like the resize event is gonna be an event that I'm gonna add to the view, but then it should change these things as well. That's the problem. Here I think that is updating the position based on the use stick, which allows you to manipulate the cycle of the animation. So I need to understand more how the use stick works there on here. But maybe you should understand the other stuff more better first. Yeah, I need to understand the other one so I understand more how this works. This is making this equal to the callback here, which is probably going to be the function passed inside of this thing. So it's like, what do you want to happen? And this is the stuff that is updating the drawing or the element there. So the question is, when you resize the canvas, or when you zoom in and zoom out, are these positions here, or because that's the thing, the vertices here are from, like it's a method from the body in the Matter JS simulation there, because of this thing. So body.current, which is B, contains the vertices, which are the current positions of each thing. So when the canvas is resized, the position here changes automatically, or do I have to update? I think that's the question. And it looks like it updates automatically through here, because even though the other stuff there is like fucked up, the boundaries, the node is still like, I still can click inside of the node and the edges are still being drawn correctly. So I think it updates automatically based on the, but then like the boundaries don't update automatically. So That's the thing. So why are the elements being drawn correctly, but the boundaries are incorrect? I think it's because this doesn't change the size of the thing, so on the zoom event probably will fuck up the position of the nodes and the edges. I think that might be what's going on, because otherwise it would update the boundaries automatically when I change the width here for the thing, but it doesn't. So I think I have to manually update everything. Like I have to synchronize the event on the app view, app renderer, and the Matter JS positions based like inside of the use stick here. So maybe I should access the app context instead of these things and then update the positions of the Matter JS based on that. Or maybe I should update. Yeah, I think if I update the world positions, I think it updates everything else. So it's probably through here I can do. Yeah, because this is the stuff that is updating the engine at each tick. So I think it has to be inside of here. Or maybe it does automatically. So let's see what this function does. Yeah, I think maybe on the bodies is gonna be better. Because it looks like the engine doesn't have anything related to the coordinates directly. It's more the bodies probably. Because I know that the vertices are the stuff that you can get the coordinates. So here. It's the body, which is the circle. And this has the vertices property. The thing here is that like there is this scale function here, so but I'm not really sure like if it is related to, because it might be more for scaling the physical properties like it is saying here instead of just updating the view. I think that makes more sense, so it might not be necessary to call this. But if it is necessary, then like it brings more questions, because if I put an event listener on the world to update the view based on the app, then how I'm gonna trigger the same event at the same time on each body of the simulation? Like that's the challenge. I guess I can call this inside of the thing, but then like the problem is the rolled components is outside of the thing. So like by the time the event listener is being called, the bodies don't exist yet, so that's the problem. So if that's the case, then I might have to put the event listener inside of the body and then update the view from the bodies. But that's also seems weird, because then you're putting like the same event on a bunch of different bodies instead of putting it on the camera. So like it doesn't make sense. Maybe you can just check to see, like, instead of caching the positions, I'll cache the body here. That's what I'm thinking about doing anyway, but if I can do that, then I can check to see if there's any bodies on inside of this node's position. And then if there is, I loop over them and update the scale by calling this function here and passing the body and the new scale. That might be the way. Yeah, so this is the same pattern that React Fiber uses, and the reconciler is probably coming from the React. I forgot which library, but it is a React thing that is used to update the virtual DOM. It's on the virtual DOM, the cycle of update on the diffing algorithm. I think this might be the thing as well. Like you create the event, or you emit on the event on the world, and then at each nodes and each edge I add their own to listen to the event. So the world emits the event, and then all of the objects inside of the world listen to the event. That might be another way to do it. I think I understand how he's achieving the zone here, is using this class, then calling these functions from the class, and it does automatically. I'm not that concerned in being able to do visualizations or add events. I think that's not that difficult. I can probably figure out by just trying a bunch of different stuff, and then like eventually some of the stuff that I try will work. But I'm much more concerned right now in understanding how everything works and how everything is connected, so I can think about how I should be adding stuff here. I think only once I fully understand, or not fully, but like once I understand really well how everything works, then I start trying different stuff. But before that, I think it's better to just keep studying, to know how it works. Problem is that like there's a lot of stuff to study, and it's very complex how everything is connected, so it's kind of difficult. But I think eventually with time it's gonna get easier and easier the more I study this, so I think I need to... I lose track as well because there's so much stuff, so like there's so many things I wanna explore. I was trying to understand how like this application here is gonna create the views at the low level in the WebGL thing, and trying to understand how like the interaction is done. Because from the documentation it says that you should access, and even in the code there, you should access the interaction through this renderer, but here it doesn't have anything like that. So I can imagine that is one of these classes or files here. And the whole thing about the plugins and the extension is kind of confusing as well. So like it's hard to just stay on like one thing at a time, because there's a lot of stuff to look it up. So I think the main thing that I want to understand now is how the renderer is related to the interaction manager, and if I need to use this other library here to do the wheel event. I think the one way that it would work is to just install the library if I haven't already, and then import here, and then I set it up here in the same way that he did there inside of the class. Or just create a viewport inside of this use effect here using the app, and then I call the functions here. I think that would probably work, but I want to see if I can access the interaction thing from the renderer, from this thing here, like this, and then set up the event based on this thing. Like I want to understand more like how it actually works before I try to implement this stuff. I understand the connection in the low level of the WebGL, the renderer, the view. So you can close the one that has the application. Yeah, I think the screen as well are the main components and the view. So like the question is why though? Why have these three different things? Looks like... Okay. I think I'm gonna stop soon. Probably... Just gonna see if this works. If it doesn't... Or... Either way, I'm just gonna stop here. Obviously, I'm gonna continue to study this until I fully understand everything. I think if by Friday I don't understand everything really well, I'm just gonna change the visualization to do the update on Buildspace. But my main concern is, like, I wanna get the fundamentals really... understand the fundamentals really well, so that's... Oh, it looks like it works, but it's fucked up now. So I wanna understand the fundamentals really well, so that after that like, it's gonna be a lot easier to implement everything that I'm thinking in my mind. So it's like one of those curves where, like, it's linear for a very long time, and then once you understand everything, then it starts scaling exponentially. It's like an S curve. So I'm just on the linear path now. I want to get to the point where I understand everything, then I can build a lot faster. I think it's better than trying to build stuff without understanding first. Probably. So interesting is that this becomes undefined. Don't know why, but yeah. It works for a little bit and then it becomes undefined. So I guess it's just because of the context or something like that. So I'm gonna stop here, probably gonna come back tomorrow. Maybe 2 days from now. I'm gonna continue to study this stuff here. I'm gonna watch these videos off stream, so... Yeah, kind of weird that it becomes undefined. Maybe it's because I'm doing this on the use effect. So I should do it outside. Like here. No, it's still the same thing. Yeah, I'll see if I can fix this off stream with ChatGPT. Probably gonna come back 2 days from now, or maybe tomorrow, so continue to work on this.